All right, we are live now. So, hey folks, this is me, Vishwas Nahan. I'm the host of this MLOps Meetup 001. And guess what? There's always a different definition of MLOps coming up in the market, ML and operations and things like that. But there's always a new demand that is getting created in what do you call in the meetup space in the industry and things like that. So we wanted to demystify all these things with some hands-on demos as well as some sliders so that you can understand what it is. And thanks to Pratik Jain sir for he's there here, so he'll be coming and talking to you folks now. So thanks to NVIDIA Inception team for giving us this space in the meetup. Also it's a great place to hang out with people. Bunch of professionals are here, of course hand countable, very less people here, but we are enjoying the presence of the meetup that we are just having in NVIDIA. Thank you so much, and I hand over it to Pratik sir so that he can give a brief introduction about NVIDIA Inception here. So yes sir, the screen is shared now, and this will be the slider, and you can take off with respect to this. And wait, let me just do one thing. It's not Vishwas Narayan. It's now Pratik Jain. Is it right? Pratik Jain. So P is capital. J is also capital. And that's perfect. And I hand over the slide deck to you, sir. So you can take it up from now.
Sure. Thank you. Thanks a lot, Vishwas, for arranging this meetup, and thanks everyone for coming, whoever is here, and also thanks all the online folks for joining in. So before I begin, I would like to just ask a small question. Whenever you hear the name of NVIDIA, what comes to your mind? Like what NVIDIA is all about? What comes? Anyone can answer.
Hardware CUD, CUDA. Actually, few examples, GPU,
Okay.
even Jensen Huang.
Okay, nice. Okay, so briefly, let me just brief about Nvidia. Most of the people like whenever they hear, they think about, as you rightly mentioned, it's a gaming company or it's a chip making company, but it is beyond that. It is even more than that, right? So as you can see in this slide, we started with the hardware, which is the GPU, CPUs, and the DPUs, and then on top of it we also have the system software, right? So and then on top of it there's a platform like NVIDIA HPC, like high performance computing, NVIDIA AI, and now NVIDIA Omniverse as well. And beyond that we have application frameworks as well, which is specific to say healthcare or robotics or AI, ML, IoT. So it's a full stack company which is providing all the solution from, I would say, from start to end. So it's not only about the hardware, which most of the people still know that Nvidia is only making hardware products or in a way, but it's a complete, I would say, a full stack company, which is a and we are mainly focusing on AI going forward, right? So just wanted to give a brief that it's beyond hardware, right? Now, coming to the Inception program, so NVIDIA Inception is a program which is specifically designed for the startups, and it's a completely free program. There is no stake or fees involved in it. It's a global program, right? Across worldwide, as you can see numbers, we are working with more than 12,000 startups worldwide. In India, we have just crossed 1,000 startup mark. So in India itself, we have 1,000 startups part of this program. And as you can see, the startups are from more than 100 plus countries, which are part of the program. And yeah, the growth rate we are seeing like year on year is like more than 59% or so, right? Okay, now what startups get when they join the Inception program? So there are like I would say, three things, which is like build, grow, and scale. One is, of course, they get a lot of free access to the NVIDIA DevRel forums, NVIDIA trainings, and all the technical, I would say, there's a lot of guidance which is provided from the solution architect. So that is one thing which is in the starters which are at initial stage, they can leverage all of this part, right? Then comes the grow phase, wherein the startup has already raised, say, Series A round of funding or angel funding is in place. Now, further, they want to grow. So we also have a VC alliance program wherein we are partnered with venture capitalists, and then further the startup applies and we connect them with VCs, right? So for further growth, so that is also in place. And also there is a lot of market awareness which we give, like on through social media, through PR, through, so there's a lot of I would say brand visibility the startup gets when they join the inception program. Also, in the scale phase, it's more of a one-on-one support. So once startup joins, they join in as a community member, and then we keep on evaluating their performance, and then we promote them to premier member. Once they are premier member, then there's a dedicated support the startups gets, like one-on-one essay support, solution architect support, a devrel team, and all the other supports which they need in technically plus business. So they get, and it's more of like go to market. Also, we support them, connect them with clients and their respective like industry clients in a way, right? So these are the phases, like build, grow, and scale, which is the startups can get the benefit out of, right? Some of the things which currently startups are leveraging. So, for example, there's a deep learning institute wherein startups get almost free credits, and there are some credits which are like not free, so they get at least 50% off on that. So this is for their tech teams who can avail and who can learn more and see like what new technologies and it's coming up, right? We are partnered with AWS, so there are free credits up to 1 lakh dollars. They get free credits, and there's a preferred pricing on all the NVIDIA hardwares and softwares for the Inception members, right? And then yeah, Dev Forum is always there to support, right? So these are some of the I would say like you can see the like our VC partners, some logos are here in this slide. And this is in a nutshell, like we have bifurcated the community member and premier member. So in premier member, as you can see, there are a lot of access, but in community also there are only few things which they don't get, like dedicated support, the VC connects, and there are some other like featuring them on the premier page, right? But most of it is it's there on community as a community member, right? uh, so yeah, this is almost like as the previous slide, so I'll not take this one. Yeah, the basic qualification to apply for Inception. So we mainly focus on basic criteria is the startup has to be not more than 10 years old, their incorporation from their incorporation date. It has to be legally incorporated, and they should have a website in place, and also they should have at least one developer in place or their tech team. Someone should be there, right? And then we obviously we see like how NVIDIA can contribute in that. So it's not only like someone is doing just online website something and then uh, we can't contribute in any way, then they might not get selected, right? So there is something which going further, they should at least use the some GPUs or some sorry, some product, some software, something that we keep in mind while selecting. So yeah, so yeah, so this is a website, NVIDIA slash Inception, which is this is some of the events which like global events wherein startups are showcasing. So these are some of the pics from that. This is the like customer and partners are interacting with each other. This is a social media. I would say some of the posts where they get a lot of visibility, the startups, and yeah. So this I think I have already cleared. Like we are focusing on four things: technology, training, market, and VC exposure. So this is in a nutshell what all the Inception provides. And if you have any questions, feel free to reach me, or you can always write NVIDIA Inception at the rate, and like I'll share the email ID, uh, or you can just visit this website and you can know more about the inception. Okay. Thank you very much. If there are any questions, please ask. Happy to answer.
Can you let me know how you are handling, lending your handheld support to them as such for a startup as well?
Can you repeat the question and then say the answer for that?
Yeah, yeah.
So Raghavendra sir, so you can say the question that Raghavendra sir had told like this, and you can say the answer later on. That's fine
Okay,
because they
okay.
can't hear that from there.
Okay, got it. So there's a one question which one audience from here has asked in terms of how we are supporting the startups one on one. Is it that way? So yeah, so as I mentioned, once the startup becomes premier member, then we have a lot of solution architects in the team, which completely focus on tech stack of NVIDIA and technical. They come from the that technical background. So someone, for example, if the startup is in working in a robotics phase or a robotics industry, then we have a team where who are specifically like focused on that. So what we do is we assign one of the members from the team to that startup, and then one on one they do like a call meetup, or they can then clarify all the doubts whatever the startup has. So that is like one on one, that way we are providing. We can't provide that to 1000 startups, right? So in India we are now 1000. So that way, that's why the premier is for just to focus on the those premium accounts one on one, because 1000 it's not possible
So you are
to have.
facilitating to the right kind of enablers as such.
Correct, yeah, yeah.
So as to prolifically increasing your ecosystem.
Correct, yeah.
At the same time, how could you able to support a healthcare system startup as such? Are you only biased to any technology or even?
No, we are not biased. Like there is no bias to any technology. It has to be like with AI or this way. So in healthcare also we have like Mona is there and all those platforms are there, and we have a team in healthcare as well, right? There's a global team also in healthcare. So we again the same thing. If a startup is from healthcare, we support like we loop in the relevant folks, and then they support those accounts in that way. So tech, I would say industry wise we are not biased anywhere. It is just our focus is AI, artificial intelligence, right? So it has to be tech with AI or ML, IoT, data science, robotics, all these omniverse, metaverse.
So you are ubiquitous to everyone as such. I mean, on top of which technology has to be enabled.
Correct. Okay, thanks everyone. I'll again hand over to Vishwas for further meetup. Yeah, thanks a lot.
Sure, sir. Thank you
Okay.
so much. So yes, it's time for me to change my name in the stream as well as go live with an proper input and an output to talks about. And I think yes. So let me just stop the share screen. Edit name. It's Vishwas Narayan. So back then when I started MLOps as one of the things, people used to say me, why don't you start by doing something enjoyable? So I went to all places and I just was able to learn something. So I think I'll be sharing you some things on MLOps. I think there is an I came here without any preparation, nahi. I came with all the preparation, but I didn't do any slides today because I didn't want to do that. So let's do this. So I've done so many posts on MLOps. So let me just share my screen so that you guys can see that. So there's a lot that I've done on MLOps. Wait. Wait. This is going very bad. That's your okay. It's somewhere down the line missing. All right, let's go on with it. Because once you see an ecosystem of engineers coming in one place, it's all different topics which are just getting talked, right? You know what, how can I optimize my compute resources to the nitty gritties of it? Like, you know, I just want to go out there and optimize 0.001% of my CPU out there. That's going to be awesome, right? So we all still know everybody wants to have the same old Apple phone, go out there, talk about, hey, you know what, I have the best photo in this world because Apple gives me such a great camera and things like that. But at the end of the day, it's still processing. At the end of the day, it's still going out there. But what happens in the back end is it's all AI and ML, which is running on somebody's cloud and it's getting optimized. So it's a simple insight that I wanted to just share here so that you folks can understand what it is all about that I'm talking here. So, okay, fine. So if you can see here, it's an execution model that we have: code, plan, trust, train. But at the end of the day, when you think, it's just a software over the software that is getting stacked up and that's getting optimized at the end of the day. In a meanwhile, if you even consider what happens once we go and just rig out some sort of an AI model and we want to serve it to hundreds and thousands of people, we still serve it through a software layer itself. So what happens with MLOps is we are just cutting down all the manual steps, which is mundane. That means it's repetitive, and we are just automating the training process. In a meanwhile, there is a Lambda and a Kappa architecture which is coming up. So what is a Lambda and a Kappa architecture? So Lambda and Kappa architecture. Okay, so let me just go to the Kappa architecture. So what it's just doing is it's just a streaming layer that's getting added. That means it's a real time processing, but Kappa is more of a batch processing. So we are not complicating the stuff here. We are just making sure that things get working as simple as that. So even here you can do real time with the batching and bucketing and things like that, but we are not complicating it. But what makes me even think back at the technology is the process is still the same. How many of you still remember the tools like Ansible, Terraform, Chef? And I think this is Puppet. Oh God, this is Puppet. So how many of you remember that? So were you a DevOps engineer? Okay, fine. It's I know it's very new to Pratik sir. Okay, it's still the same old DevOps. So I think he should be remembering Puppet because he has great stories. Yeah, like at the end of the day, most of my architectural reviews happens with respect to this only. So if you can think about all the process that I'm talking about, scheduling, utilization, quota management, privileges. These are all the things which I always give to my admins to be taken care manually. That means they are supposed to sit on the Azure portal, just go to the subscription, just see what's happening in the cost management here. And let's say there's some cost analysis here, and they are saying, you know what, we are not having some practices here. We are supposed to change something that will be said to me by an admin. But today I'm even automating that as well, thanks to the tools like this. So in the meanwhile, let's not discuss more of this image. You can just follow me, hashtag Azure Sketches, and also there's one more hashtag called as wait, hashtag Azure Sketches. This is one of the LinkedIn thing that I have, but there is one more thing called as which was made some text sketches. Yes, this is the one. So if you can go here, there are a lot of other sketches that I've done. Yeah, I think they're pretty good. You can start learning from all these sketches. I just did it because I wanted to learn something. So you guys can go here as well. So let me just jump on to the Azure portal. So I think there's an error or things like that. I don't want to go through all that complexity right now. So this is an regular cloud interface for any person who is working on Azure. That means somebody has an hardware, somebody is giving me access through the software interface. And now ML has to happen automated. That means I just need to write some rules and I need to write some logic behind it. So that's simple. So what I do is I just go here and I click on this Azure Machine Learning. What happens when I click on this Azure Machine Learning is it gives me an entire ecosystem that is built on Azure and it's giving it to me. That means it's very simple. I just need to have good amount of money in my bank, get the credit card, swipe my credit card, and pay monthly ones. That's the that's the challenge that we have today. monthly ones, the audits has to go, the OTP has to be there. You know, freelancing is getting very tough, right? I think he should be knowing it. Everybody is doubting each other. And also there is one more demo that I've planned today, that's Azure Databricks. Why Azure Databricks and machine learning? I'll say you why. Because Azure machine learning helps me in understanding how to build a model. Azure Databricks gives me the compute leverage. That means I can optimize my compute resources to the end-to-end resources. That means I don't have to waste any amount of compute resources that I have. It's that easy. I'll just show you in the demo. So let me just click onto the Azure machine learning, and it was already created. If you just have to just go and create it, it's very simple. Just go to Azure portal, click on machine learning, and of course there is this magical icon called as create. You have to just create here, and you are given the entire ecosystem from Azure. You need not have to work about it. And of course, if you don't know what is resource group in Azure, it's a virtual repository which has all your resources combined. That means any location it is distributed, you get the view under one resource group. That's it. It's a virtual repository. So you can create a new one and you can just say to that, and you can add the workspace name. I added which was ML workspace or something, ML demo or something here. It just reflects there. Central India. I'm choosing my location as well. I need the data center of the Azure to be in the Central India, and I'm taking the access of it. And of course, these are some things which obviously get filled up the moment I write my workspace name, because what do you think about application insights? It's saying about the uptime and the downtime of the machine learning ecosystem that is given by Azure. Key Vault is used for securitizing all the tokens and the things like that. Storage account is used for getting all the artifacts from your ML ecosystem and storing it there. That means, let's say you train a model and you want to put it in that ecosystem, you're using storage account. So now let me just launch the studio.
Meanwhile, you launch a quick question because I have been working in the data engineering aspects as well. So, why would one prefer Databricks over SD Insights or Data Factory?
It's very
Because
simple.
what I believe is it's quite too expensive when you
Data
are running more
bricks.
instances.
Yeah, like I'll say why Databricks makes a lot of impact. Let's say this is an Lambda architecture, right? Thanks to Kai Weiner, is the CTO of Kafka, Confluent Kafka. So his blogs are amazing. So do watch it. And I started using Kafka because of Confluent. And there is a lot of story behind how Kafka came into the existence, because LinkedIn was on PubSub model and they had huge latency, and now they streamed the entire layer onto it. That's where Kafka was born. There is a scientist called as Neha Narkade, and she was the pioneer behind that. Like, she was one of those people who believed in Kafka, and now she has her own company called as Confluent Kafka, and this guy happens to be the CTO of it, and she happens to be the founder and the CEO. I don't know about that, but yeah, let's jump onto this one. So it's very simple. When you look at this entire architecture diagram, okay, the question asked by Tarun sir is, why do you prefer more of the Azure ML and the Databricks, and when is that scenario and the decision made accordingly, right? This is what you asked for.
Yeah, so it's a few different services offered by Azure itself.
Yeah.
So why would you prefer the Databricks over the SD Insights or the Data Factory? Because it's ultimately what you are achieving with Databricks is the processing of the data, right?
That's
That
the
can be
thing.
done with the SD Insights as well.
So yeah,
So
like let's say this actually happens to be one of the okay diagram, but I'll show you what happening. We are still having the, even in the Lambda architecture there is real time streaming happening, but at the end of the day we are batching somewhere down the line. And let's imagine the RAM has to take in so much of load all of the sudden, and it has to process such a huge amount of data, and it's going to be so tough and challenging to optimize the compute for that only. And if you see the industry, the way the industry is also coming up, it's like my accelerometer can give up to like 1 gig of data per hour, like if I configure it right. Let's say it's a 6 degrees of freedom accelerometer, like different data points are considered and a lot of things are taken care, right? So it's gigabytes of data coming up from one person. Let's imagine there is tons and tons of data that is produced by thousands and thousands of people, and it's getting batched up in one storage account. And let's say one company has this strategy of training it every single day. So I'll show you one instance here. So very simple. You go to my Databricks workspace here, and I'm just launching this workspace. It's very simple. Okay, I'll just show you one of the mailers that I used to get from here. Okay, is there no account? Oh, okay, fine. It's a different story. So I'll just show you one of the mailers. I'm just making sure the model gets trained every 30 minutes. That's it. There's no password that is getting compromised. Yes. I don't want my password to be compromised. This is my organization account, by the way. All right, not a problem. I have my charger. Don't worry. Yeah, yeah.
So is it
Yeah, yeah.
the lambda kappa architecture because that is one part.
Yeah.
Here, exit does MLOps, right? It's where it's mainly about that you are not processing the data.
Yeah.
You are either building a model, and then after that deployment, and then after that continuous integration, delivery, and training.
Yes.
So for that, do you think that Databricks is mandatory?
No, but Databricks gives you that potential of putting the CI/CD inside it. I did a demo on attaching GitHub with Databricks. That is just GitHub token that I can just attach here. That's it. And the moment I push the code here, the CI/CD all automatically runs on Databricks. And this is the amount of leverage that Databricks is giving to me. It's not something like Databricks is not the requirement of the hour, but Databricks solved the problem.
But it can be solved through even Azure ML also, right?
But Azure ML doesn't give you the compute capability which Spark is giving. Because let's say you want to batch process data, which is 100 gigs of data, which is batched up. You need to use a lot of compute like GPUs and TPUs and things like that, right? But what makes the difference is the data ingestion pipelines are going to be so huge tomorrow as well that Azure ML can't give you that leverage. So this is where Databricks makes a huge difference in let's say I'll give you one example. Okay.
Yeah, so I got the point. So because here you're talking two terms. One is data engineering, one is ML.
Yeah.
Right. So for data engineering side, because where you get a large volume of data, then
Yes.
Databricks come into picture. But when you do the prediction, that ML part, for that also I think it will be sequential, right? Databricks followed by Azure.
Yeah, like you can still connect any amount of instances here. So it's not an like you can still connect artifactories from your Databricks that is getting trained in the real time to Azure ML as well. So it's not affecting you in any way. Like you still can do the combination of both. Let's say I'll say you one example. In Amazon S3 buckets, there is different tiers of storage like cold storage and hot storage. Why do we always put a stagnant data which is not getting accessed many times by a glacier or some other tier, and the one data which is getting accessed throughout, like very frequently getting accessed, we keep it in another tier, because everything is all about cost. To me, I don't care about like whether the Databricks is costing me $1 million a year, or else is it costing me $500,000 a year. Because I'll say you why. Because once I think about the processing that I have to do, the automation that I have to do with respect to data engineering patterns, let's say I have to put in Apache Spark in my pipeline, it's going to be very tough for me to even think about the phase in which the Spark has to be installed as well. Let's say I want to do an installation of Spark on my laptop. It's going to be very tough for me, right? I'll just give you one simple notebook. Databricks by Vishwas.web.app. This is one of my blogs that I write on Databricks. And here I have a lot of things. Like you can see error with the schema notebook. If there is a database schema which is changing every time, I can't go and write that in an ML model, right? Like let's say something has to change in the data ingestion. So it's going to be very tough in Azure
Here
ML.
we are talking two things. One is the installation of Databricks, right?
Yeah, yeah.
So see, now we are talking about Docker, right? Now Docker event, when you install Docker, so it doesn't, again, it is not that rocket science,
Yeah.
way back, probably 5-6 years back, right? So I don't think so. Maybe because as you said, is one because cost is the main thing, right? Because when we
Yeah.
talk about maybe when we productionize on any company, right? The cost is the main thing. So that is where like in MLOps come into picture, right? To give
Okay.
a better architecture.
Yeah, like there is a lot, of things that I don't know what happened all of the sudden. That notebook is ud gayi. I don't think so it's there as well. But koi baat nahi. Like we'll just go on with one simple demo so that you can understand what I'm just trying to say here. So I just took an example of AutoML here, and I think let's just go with that. Okay, what happened actually? Let's go ahead with the once again. I'll just look at my laptop whether it's conflicting. Yeah. Okay. Okay, that's fine. I got it. I got the issue now. So okay, I had it in my one laptop and the other laptop had a different AD connection, so it's इसलिए फट रहा था. कोई बात नहीं. I'll just go with the new workspace. Or else I even have the notebook, so don't worry about it. It's still going to be the same thing. What really happened to this leave? Yes, I don't want it also. Oh, wait, there are no recent things yet. What the hell is this? Okay, what happened all of the sudden? Okay, there is still updates coming up on my notebook, but I don't know what's happening. It's not showing up here to me today. It's there on my other laptop, but I don't know what's happening with this thing. Okay, it's very simple. Let's create a new one instead of just going out with it. So I am just taking in diabetes data. That's PIMA India diabetic data. So there's a lot of discussion that we can do. Of course, don't worry. Yeah, like there's a lot of discussion that we can do with respect to this data as well. So don't worry about that. So let's just select the data and think about what's happening. Okay, now it's selecting the data asset. That means we are just putting in the data. So there's a new experiment coming up, which was targeted column. I put it as Y. And let's say I want to do something like this. Here I'm choosing a compute resource and I'm saying the compute name is Vishwas and I'm creating a compute resources. What I'm just doing here is very simple. I'm allocating a compute resource for my compute to run whenever it's available. Let's say I ingest a new data, there should be something running. Also, I don't ingest a new data, don't run it. Reduce my cost. That's what we want, right? Everybody's trying to reduce something or the other. That's cost at the end of the day to me. So in the meanwhile, I don't know what happened to my Azure, man. Azure is so bad. It's not it's not showing on this laptop. It's showing on that laptop. So bad this thing is. I had done a demo. I don't know what happened. But yeah, TK, by then it will just get things sorted. So yeah, I think it's done. So since I choose Y as one of that variable as the output that I should be considering, classification happened to be the standard, but there is also a regression that can be used. But classification is better. So let's say, of course, if you can see here, there's natural language processing preview. That means it's not yet at GEA. That's not generally available to anybody. It's still under preview. And if you can see here, there is computer vision as well. That means the folks who are always into the computer vision can still do AutoML here. So I choose this. It automatically says that you're not eligible to choose natural language processing because it knows that data. It knows the pattern of the data, but it's not done that insights yet. So let's choose classification and I put next. And of course, if you think about what an ML process is all about, there's always a validation layer that comes up. That means the amount of data that I ingest in, some amount of data has to go for testing it. And guess what? There is not just one strategy, there are multiple strategy for it. K-folds are nothing but the kth number. Like that's like the specific numbers are just segregated out and they're just given out as one chunks. That means one set of data gets trained on one k folded value. the other chunk of data gets trained on another iteration and things like that. But Monte Carlo, train validation split, user validation, that's also there. But I would say cross validation, or else auto would actually work fine here. So I'm just splitting the data. Like, let's say I want 10% of the total data to be going for the testing, and I just want 90% to get trained. And I just did it right now. And guess what? You still have a set of compute here that is just running for you. That means to me, I did not have to set any pipelines here. You can see here, I didn't set any pipelines. I just went to the AutoML and I started rigging up an experiment. That means it's not yet started because the compute has to be loaded up. The things have to come up. But let's see, let's hope that the things work out. And I don't know why this thing stopped running all of a sudden. So let me just rerun this so that I can do one fatafat, I can do one ML flow demo, and we can go for one DVC Corp demo as well. So let me just go for the ML machine learning, create a notebook, say Vishwas Narayan. Of course, that's my name. That's not a best practice, by the way. If you are putting in anything in your industry standard, don't put your name in, put the pipeline name or something like, let's say you're putting in the data of some smartwatch, accelerometer, or something like, I think Madam was a doctor. I think she could have given me some sensors out there. She's not here. Your mom. Yeah, yeah, not a problem. Some sensors, what do you call? Pulse plethysmography, PPG sensors, which is used for getting the pulse using plethysmography, something.
So the default language you're using, you can use Scala and SQL and all those. What are the download it's showing? Okay.
It's a SQL Scala R, but there's something called as magic functions as well. Magic functions in on Jupyter. So it's a Jupyter instance which is coming up. So let's say magic functions is something which is saying you percentage. I say Scala. You can write a Scala text onto it and you can just leave it. Wait, I'll just show you in one of the things. I think there's a blog. This is a blog that I've written. So you guys can use that. I don't know where's this thing. Okay, you can just see here. This is one of the notebooks that I just wrote for Databricks. It's here. So it's just one of the notebooks that I written using Databricks, and it's all SQL, by the way. It's all SQL, and I think this is Spark. So this is actually Python here, but yes, there is SQL that I've written. So the magic function that I was saying here is here in front of you. So you can still do multiple languages in one notebook. Like, let's say you want to query something, like he was asking about like why Databricks makes a lot of difference. Let's say I want to put more of the SQL workflows or something like Python workflows. Let's say one TensorFlow model has to get trained in one notebook. Let's say multiple ingestion layers of different data sources. It's very tough in Azure machine learning. This is where even Azure Databricks makes a lot of impact here. Yeah, I think I'll just share it in the places. So don't worry, I'll just share it in LinkedIn. I think there's one more. If you guys want Azure ML Vishwas.web.app, this is one of the blogs that I write on Azure ML. So it's like an end-to-end notebook. So you just can directly copy this notebook. Just go here, click on the notebook. You'll just get a notebook view of this HTML script. Just go copy it. Of course, you have to change some subscription ID, tenant ID, resource groups, and things like that. And you're good to go. MLOps is easy peasy. Like, I'll be very frank with you. This has been viewed by most of the Microsoft folks as well. And some of the sessions and some of the blogs have also referred this blog that I've written. So don't worry about it. So there's a lot of things that we can communicate here. Bye. So Amulya ma'am went off. Bye. All right, folks. So wait, let me just go for the Databricks so that we can just create a notebook and we can just do a demo so that by the time this gets trained up, like this is actually setting up the run. So by the time this gets trained up, we can just create one endpoint or something. We can also test the model as well. By then we can just create a notebook and we can just get it started. So simple as that. So in a meanwhile, let's just do a Databricks demo itself here. So I'm just saying to my dear Databricks, import me all these things. And guess what? This is a new compute instance and there's no ML flow inside it. So this is where things make a lot of difference. I have to go here. I think there is an installation which is already done, or else if it's not done, I have to run it again. Okay, it's already done. That's good. Okay, so now I'm going to set an experiment here. That means experiment is going to be a tab in your data bricks, which is going to collect all your artifacts. How many of you have worked on JFrog, Nexus lifecycle management, or things like that? Like repositories or anything. So in your software definition, there is going to be a lot of artifacts, which is respect to POM XML, this and that, jar file, toml file, what's not. Python के लिए तो wheel file तो जादू बन गए. So what I'm just doing is I'm setting a repository right now on Databricks. This is where experiments come and play a major role. So it's working. That means that if I can go here and now I just have an experiment set for me. That means there's no artifacts here. Oh, okay. There was already something running prior to mine. I don't know why it didn't show up on this laptop, but I could have made this demo very early. But yeah, like I don't know what happened all of a sudden. So let me just do a simple ingestion of some data so that you guys can understand what are we just trying to achieve here. All right, so I just took this notebook. Let's do this quick, so that we don't waste a lot of time here. So, all right, it's here. Okay, it's very bad. Too many tabs open. That's the whole problem. So let me just go here so that you guys can start running the application. So we are now running this. And okay, diabetes.head is just going to say the 5 numbers of data, like starting 5 data is getting seen here. Okay, let me just go to the next step, man. Like, don't worry, I'm just taking the general scenario of an ML, right? X train, X test, Y train, Y test, and we are now doing that. Very simple. Just go here and just do that, and I just segregated it right in front of you. Simple as that. And I'm doing this, and guess what? I don't have to do much here because starting 0 to 5 I don't have to see as well. So let me just go and do this. Okay, why is this thing taking so much time? All right, let me just do this so that I can just do it fast. So it's now saying not indented properly because I copied it from the notebook. So let me just do shift tab and tab. Guess what? My artifacts are getting stored right now. That means, let's say you have hundreds of different pipelines which are running and you don't want to really mess out with the artifacts, right? Let's say you go to an experiment and you think about one sklearn model which was having, let's say you have deployed it using DL4J or something, like it was a JavaScript application, Java application, not JavaScript, Java application, and it had some DDoS attacks or something, and you want to remove it out as quick as possible because that's not good for you at all. And let's say you click on it, and guess what? You are going back to this artifacts, and you are getting all the things that is required for deployment, right? This is what you do. If you go to the Heroku, you still put the model.pickle, environment.yaml, requirement.txt, and ML model. Of course, this is what you put in the artifacts there in the Heroku, and you are getting everything. And let's say I want to register a model, and I want to say I'm saying Vishwas or something, and I'm talking data at the scale. It's like 1 TBs per second. Okay, let me just ask you one question. How much data is just getting collected from an aeroplane every half an hour? Any ideas?
Petabytes.
It's not petabytes. I'm saying every half an hour. I'm not saying the lifetime petabytes. I'm saying about the half an hour flight is going to give you 1 terabytes of data. And I'm saying static. Hey, my friend. Hey, auntie, bye bye. Hey. Bye. Okay, I'm just giving talk. I just wanted to meet them. But yeah, sure, not a problem, my friend. So so think about it. If you are ingesting data into different pipelines and you're just talking about the scale all of the sudden and you want to optimize compute parallelly, it's impossible for me as well as the other guys. So what we do, we just throw as much as money we can and we are optimizing the process as fast as possible and optimizing the compute. That's it. Simple as that. So we got that, and the best part about it is we can do as much as we can. Like, let's say I just had this thing running. So let's say I just go mad about my models and I say I'm going to write everything in sklearn and I want to know what is the fate of that model exactly 10 years down the line or else 20 years down the line or else, let's say 20 hours down the line. There's a data drift and a model drift concept in the data science world as well. Very simple. Data drift is something like I am Vishwas Narayan and I'm staying in India right now. And let's say tomorrow somebody sees me in Canada as a student, they should not think me like I'm a terrorist out there, right? Think about it. And now people start thinking me I'm a terrorist here. And that's not the right data, but at the end of the day data is getting stored as terrorist Vishwas Narayan, and probably the prediction model is going to say he's probably aligned with some stupid folks in the terrorism world or something, and I don't want that to happen. And let's say that drift is happening, I have to know that. This is where you get to know. This is where MLOps comes into the picture. So let's do that. Let's do this auto logging thing, so that this will be the last demo before the DBC Corg, and we'll just wrap up the things. That's it. So I'm copying this and I'm indenting it properly. That's it. I'm not doing much. And there you go, my friends. I am just getting to know what's the ML lifecycle that I'm just putting in. I'm just putting in my model at stake, data at stake. Let's say I want to know everything in one space. Guess what? I just add it in a fractions of time. This is where Databricks has a huge potential in data processing. Like, let's imagine it has to process all this data. Would it happen in this amount of time? Like, that's a question to an Android developer. If you anybody Android developers here? Any Android devs? No Android. I was a Flutter developer and I know the pain of hot reload not working. And guess what? This happened in front of you. So this is it, my friends. Let me just go to my GitHub so that I can show you a last demo on DVC Corg so that you get to understand what is happening with respect to. Okay, let's do Vishwas 1 2 3 4 5 6 7. Okay. Hey, password getting compromised anyway. Sorry for that. Okay, Vishwas. Oh, sorry for that. All right, my friend. Asking for a two-way authentication. That's good. Not a problem. All right. I just copy this. Yes, it's getting updated. And of course, I have a lot of demos. DVC. There's a DVC cog demo. Okay, fine. Let's go to my repository so that I can have a very fascinating look about whatever I have done. Okay, before going hand, this is one of the Docker tutorials that I have written. Like end-to-end Docker learning can be done here. That means you need not have to worry about anything here. You just have to go click on any topic that you want to learn. And let's say, okay, this is something. Okay, this is an org file. Any org file, you just can go click here, and guess what? You get an brief view about every little topic that is supposed to be there. So let's go here and repositories. I forgot the DVC Corg. New web app blazers.net static. I've done so many demos, I've forgotten where it is. ML5GS private. Demo CML, yes. Continuous machine learning. So let's say I have a pull request, three pull requests, and I have some set of data which is coming up here. And these are the set of artifacts that I have right here, right now. And this is the amount of changes that I've done. Let's say there is a set of developers who are coming in every single day and they're doing so much of changes to you. It's going to be so chaotic. So at the end of the day, you need that. Okay, let's just do a simple demo of pushing the code and we'll just go on with it. And you guys can go push some code and you can just still learn something. Okay, let's just go for github.dev. And if you just go here, it just opens an developer console for me in order to get the VS code on spot. That's it. So simple as that. I just go here. I don't want to do the clone the repository, status, commit, push. No, I don't want that. So let's say I just put one more space and say Vishwas tried something, and I don't want to do anything here. So yes, it has detected the changes and I'm committing the changes. And I'm saying Vishwas demo one, and I'm just committing the changes. And guess what? It just committed. And if I just go here, just type com, guess what? There's a new pipeline run that's happening. This is because of GitHub Actions. And you can see here, this is what is happening here. So very simple. It's a run pipeline that I'm just doing. So it's initializing a container for me. That's there is a base image of DVC core or the Linux, which is just getting updated for me, and I'm running everything. So if you want to know where is this GitHub Actions is running, it's .github/workflows cml.yaml, and you can see that this is the house price prediction model that I'm running right now, as well as there is a continuous machine learning Python image. That's the latest image that I'm running right now. And guess what? I'm putting in all the artifacts onto the report.md. That's it. You know that command of two greater than, yes, that's the greater than symbol is going to, let's say, pip list greater than requirements.txt. That's what you do, right? Once you are going and deploying a model. So this is what is happening here. And let's say I just go here, and if the pipeline is complete, let's say there are some runs which are happening, see all checks and hide all checks, that's okay. But okay, yet to write the readme.md merge. I just merge the pull request. That's also all right. So there'll be one more pipeline which will be running. So this used to show an list of artifacts which are there associated with this experiment, but you know what's happening here. So let's say there is two pipelines running, just the one. Okay, where's this actions pipeline? Okay, this didn't run. All right, let's say what happened here. So process completed with an access code one, and okay, there was an PyPy issue. This keeps happening, right? You know, let's say when you're in the software delivery life cycle, just go out there and you're just writing in some set of code. Okay, it's not written. Why? Okay, let's do one thing. Let's go to a different branch and see what's happening here. Man, what's happening? This has to come up. Okay, I don't know why the artifacts are not coming anywhere, but ठीक है कोई बात नहीं. I think, oh yeah, it's here. So every little pieces of the artifacts respect to the, what do you call, this, graphs, as well as the system level information, the midway of the prices or anything is just getting here. That's it, simple as that. So you guys can learn this thing anywhere, don't worry about it. It's still, you can just go here, dvc corg, and so sorry for that, dvc ml. So data version control. So this is one of those organization which is contributing more towards the MLOps as well. So that's the demo that I showed here. And if you can go to the ML thing here, it's training now. That's good. Fine. So whatever it is, if it's available for me, I'll just get it to you soon. Like we can do that. And I hand over my session to Raghavendra sir, who is going to talk about
Simulating performance.
simulating performances. So let's
Offline profiling.
offline profiling. That's good. Kiran, right? All right. So the stage is yours, sir. So let me just change the name in the stream so that I can give you the access right away. So I'll just stop the share screen and I will edit name. Can you write your name and perfect. Let's go on now. So I'll present you the screen so you guys can go here and you can start with the 1 second. I'll just do that. What is this? Okay, wait. Display setting, duplicate slideshow. Yeah, this is perfect. Yeah, this is working. Sure, sir. The stage is yours.
Yes. Good evening to one and all. I am Raghavendra, working as a data scientist for FIN Global. Today, it's been a while. We have seen, I have seen all the great folks as such, as we have witnessed a couple of years lean patch in the lives of human beings. So I'm very feeling honored to be among with you as such. Today, I'm going to demonstrate a project which is related with that of MLOps, simulating performance of ML systems with offline profiling. I just want to help you out with the help of slides as such. This is an MLOps concept. So moving forward, actually, I can say that MLOps is the perfect intersection of machine learning, data engineering, and as well as DevOps. So it has got the capacity and as well as the capability, wherein which you can able to deploy any machine learning project in productions with the help of collaborating DevOps engineer and even the operations team. It's just the collaboration of a like-minded people with data science engineers and as well as DevOps. There they can able to share their knowledge and as well as lot of strategies how to im- import the data, ingest the data as such that can be treated with the help of this MLOps. As that for each and every project, there are stringent processes that has to be followed, especially development, testing, coding, and even the support as such. With MLOps, we can able to integrate everything, encompassing each and every of these activities
And what we can do is the gamification of the entire project and as well as the product for a agile based or even in scrums can be done with a streamlining management such so as to keep track of emerging and as well as evolving procedures in the technology in the space of technology and as well as in even in DevOps as such by meeting the high business value and providing the value proposition to the customers as well. Actually, and even the regulatory standards can be met with without any compliance as well. Even this MLOps itself is a iterative and recursive procedure wherein which the development takes care of that data right from the data cleaning to developing of algorithms training and as such testing can be done even ETL procedure extract transform load with data pipelines continuous integration and continuous deployment can be done even for a DevOps team especially continuous delivery model inference monitoring and management these are all the activities which can be done within a specific timelines so that we can so as to avoid the unnecessary usage of timelines as well what are just going with the of benefits and advantages of MLOps it increases the productivity with enabling data scientists and as well as machine learning engineers it just acts and it has got the facilitating feature to boost the productivity and thereby even the performance as well creating automated pipelines it gives you uh, in some more ML models where we are supposed to create a repetitive task as such numerous repetitive tasks will be there so it gives us the advantage wherein which we can able to take it off from a by following the entire procedure manner at the same time the entire workflow can be orchestrated automated and orchestrated this eliminates the time and as well as the errors so we can able to add more value and as well as the project efficiency and efficacy will be increased even the expenditure will be very less so there is no need to add additional resources and at the same time we can able to scale up the needs of even version control as such with the help of all the features have been embedded in the ML modeling itself and no need to buy the additional hardware and software for delivering model versions some of the a remarkable portion of the operational costs can be saved even the code reusability can be done reproducibility the deployment of a machine learning model is a reproducible and repeatable with a simple workflow that we are able to handle and will give you certain procedural activities as well so that with the help of a documentation even the DevOps engineer can able to deploy or even he can able to reproduce the model this contributes to the increase of productivity not only the increase of productivity but even it helps the to enhance the knowledge and as well as across all verticals of the company the reliable features MLOps increase the reliable features of ML pipelines reducing the human errors as well so human intervention even the human intervention will be less when compared with that of previous procedures so allows us to gain real insights into the data by ingesting the data in data pipelines as such and simplifies model management procedure for consistent scaling upscaling procedure as well connectivity MLOps allows distributed employee teams to collaborate a common delivery model, wherein which across teams like even marketing, sales, and as well as coding, testing, and they can be part of our MLOps, so that they can able to learn how to manage and keep track of all the ML model. It shortens the deployment time and lowers the deployment costs as well. For further proceedings, he can be able to collect the data and train the new models independently by working together on a common distribution model. So all the departments can be able to associated at an ease. So, and even they can able to work on a rapid innovation manner by quickly and efficiently collaborating as well. Monitorability. So MLOps provides us the information about the model performance by continuously retraining the model to ensure the most accurate output as well. S- So, what are we are trying to achieve is something which is related with that of efficiency and as well as the efficacy. Efficacy handles the most desirable factor of a product. So, according to our customer needs, we are supposed to provide that. Excuse me. If there any model drift, signals are sent so that we can able to track according to our requirements, and as well as even the specifications will be monitored according to us. This ensures the better process by following the best practices as such, and high quality results will be yielded. In the project context, machine learning systems are prevalent, used to train the complicated DNNs as such, using a cluster of machines. In the in this context, characterizing the performance of a ML system becomes critical for optimizing training strategy and system design. So we are trying to intuitively monitor the performance, and thereby obtaining the results that we are looking out by training a DNN model as such. In this project, we are trying to advocate the simulation based on offline profiling, which we are trying to run our application in a remote manner, remote procedure, with a special library parameters passed upon, and there should not be any the approach should be better visibility, and it should, and there we are not any more compromising the complex, we are not compromising on the outcomes as well, thereby improving the complexity. Our approach uses operation level profiling and data flow based simulation to ensure it's a unified and automated solution for all frameworks and ML models, and also accurate by considering the various parallelization strategies in a real time and real time system. Offline profiling is to measure performance of basic execution on units, different hardware platform, and based upon it can even be in the simulator can be output can be even given to a emulator as well, so as to improve the overall performance accurately, characterizing the system level performance without any compromising factor as well. Let's deep delve into the designing. The designing process itself is a psychological and as well as technical art and science, wherein which we are trying to monitor everything with the help of a simulator entails. So here comes the two basic questions: how to profile the basic execution of a units of a DNN offline, how to simulate the system wide performance using the profiling results. Answering them is very challenging as such, because we need to have the achieve three objectives at the same time. The simulator should be accurate in order to be useful. it should be general in order to cover the major dimensions of ML training: framework, library, hardware, training strategies, etc., with the help of methodologies, and as well as implementing the components as such, with the components as such. And even the performance can be monitored, should also be efficient with minimum human intervention, preferably completely automated in the following. We can explain the key aspect designs in answering the two questions and how they achieve our design goals as well. Operation level profiling. There are two types of basic execution units for a ML system. One is operation, which is the atomic level execution defined at the framework level only. Example, we are making use of TensorFlow as well. The other is kernel, which is defined at the device level. So we are using the CUDA architecture, which is of NVIDIA's. That's a parallel platform, parallel platform, and even the APIs can be used on top of it. So as to enhance the productivity, it just ingests the data from CPU to onto the GPU kernel, wherein which we can able to handle the computational speed, and even all the operations will be performed over there, and it will return back to the main memory of a CPU as well. So this how the entire technology trades off between CPU and GPU, especially in a CUDA architecture that's of NVIDIA's, so as to have the accuracy and overhead procedure. We don't need to favor any kernel level profiling because it requires precise knowledge, and even it has the cost factor as such. So we are trying to, this can only be, even we are trying to optimize the entire framework's source code, which is extremely, which cannot be done as such, even for a single by practicing the convolution 2D
It's not working. Slides are not working.
Yeah.
It's not working.
Yes,
It's not
actually, right now.
okay.
No. By practicing the best method of convolution 2D operations in TensorFlow, has got 4 arguments for the input tensor shape, even for the filtering kernel shape, and several other arguments for other attributes of the 2D convolution. Thus, we apply a machine learning approach here to reduce the complexity for each input argument. We profile a fixed number of values and artifacts as such, and use these results to train a neural network to estimate the operational performance, so as to automate everything as such. And the design details, as explained, data flow based simulation. Another key design choice is to use data flow graph on the basis of simulation. So what we are trying to ingest is, with the help of a data flow graph, it we are trying to induce into pre-processing module, and even the environment configuration will be set on top of it, and strategy configurations. So what we are trying to achieve, widely used ML frameworks as the blueprint of execution, and is generated automatically according to the user training process. It is directed to the eclectic graph containing the operations as nodes, and input output data as the edges between the nodes. It also represents various parallelism, optimization, and distributed execution strategies across the devices and machine. Every node on the graph can be placed and on a different machine, which is the indicated according to our device property, and synchronization requirements are modeled by dependencies across computation and communication operations. All this information is embedded into a data flow graph, which can readily be obtained with the frameworks API, so as to make the innovation happen. Thus, our simulator essentially works by replaying the entire training execution based on the data flow graph to calculate performance. Each independent device actually it either may be CPU or a GPU communication execution happens in parallel and maintains a job queue as such, and it's the finish time will be calculated according to that. The simulator keeps a global ready list of all containing nodes whose dependencies are fulfilled with the help of a looping structure. So this itself is an iterative and a recursive procedure. It all starts with a node in the ready by enqueuing them in their corresponding device job queues. As soon as an operation is finished on device, it updates all successor nodes. A to Z dependency, A to Z dependency counter will be
Just continue.
happened, and the counter becomes zero when the successor node is added into the ready list, so that so as to keep stacking up according to the requirements. The system performance is obtained by looking at the finish time of the last device as well. So these are all the key performance indexes that we are trying to monitor for overall system design as such. By our simulator's overall design is shown as such in the last diagram. So as each framework expresses data flow graph differently, the pre-processing module as transforms the data flow graph extracted from the framework into a unified format. The operation estimator estimates the performance of each operations in the data flow by querying profiling database with the offline profiling results. This requires information about the training environment. Example, we will be configuring on top of a lot of hardwares, and as well as the software libraries, and even the versions will be different for a configuration file, which is not in the graph according to. In such case, we has new operations not in the profiling database. At times, we may even fall back as such. We are trying to just handle the situation, how resilient the systems are as such. Even the online profiling requires a lot of complexity, and it will not scale up. So that's the reason why we choose. Even the operation cost will be of huge when compared with tough offline profiling. So that is the main objective for us to choose the offline profiling with new operation profiler and add the results to the database. Then simulation model takes the augmented graph and simulates the training execution accordingly and estimate the performance as explained. It also needs an additional information about the training strategy from a configuration file, such as the number of replicas in data parallelism and data pipelining as such. Setting up the standards for model parallelism, which may not be available as per the data flow graph. These are all the results that we have synthesized according to the experiment that we have done on a server with two Xeon CPUs, E5 2620 and 4 Tesla V100 GPU running on Ubuntu and with CUDA architecture on top of it. And the TensorFlow is the framework that we can able to just we can see that it is visible over here that the graph has been the traditional graph has been phenomenally increased to the where we are trying to achieve our goals and objectives as well. So these are all the configurations and even the performance of convolution 3D on our test bed. And you can able to manage the we can able to track the throughput of GPU communications on a single machine according to the different scenarios as well. So just see the throughput has been increased with the minimum minimalizing the error percentage as well. Graph that only contains the data input nodes and even and thousand identical computation nodes corresponding to the operation. This is to amortize the constant overheads of our of launching the graph according to the data input. And input initialization on GPS before training starts as such. As discussed in S2, we profile the input argument of the operations and with 16 possible values. Our initial experiment profiles over 20 common operations for a neural network building. Relu, sigmoid, convolution 2D, backprop, filter, etc. These are all the examples where we come across that linear algebra and element-wise mathematics has been observed. We are trying to achieve that goal as well. By observing the performance is very stable and even the standard error lower than 1% of the mean. This gives us the efficiency as per our objective of the project and has a strong linear relationship to the input. Figure 2 depicts the performance of convolution 2D with varying number of input channels as an example. So I'll show. Here the input channels have been increased from 0 to 48, 96 and 144, 192 and 240 respectively. So that we can able to this verifies our design as such according to the model that we are trying to accurately estimate. We also profile the GPU communication bandwidth in a single machine under different scenarios. So here the table one, here the throughput of GPU communications on a single machine in a different scenarios can be monitored
Sir,
and
this is
managed as
research
well.
paper.
No,
This is a research paper only, right?
we on top of it we have done some of our inputs are there.
Oh, okay, okay, fine, fine. I think there should be some references, so that's
Yes,
why I
yes,
just asked you. That's it.
yes. Actually, with the timeline to measure the actual training time, since our profiling is not completed, yet we use offline profiling results whenever applicable and reliable on timelines as such. So this off and on top, what we are trying to conclude is by seeing offline profiling based simulation for ML systems in this task provided. To fully demonstrate its feasibility and potential, we are conducting extensive offline profiling to cover all the operations in popular frameworks and common hardware and investigating the ML approach for operation level performance estimation as well. We'll also trying to validate and verify the effectiveness of our project of our approach for the project in distributed settings with multiple machines and various networking technologies. So as to keep developing a fully automated simulator together with profiling database and open source it for the community. For actually, we are tracking with the help of DL open source projects only, ML open source projects, and even deep learning open source projects for this. As I am citing this as a references for this concept as well. Thanking you.
So, all
It's
right.
it's
Yeah.
time for me to hand over to
Vishwa.
Vishwas Narayanan as well.
Narayanan, maybe Narayan is
Okay.
my name. Okay, fine. Okay, there is a new speaker coming up, and I think it's going to take some more time. How to connect VCs from inception? All right. Okay, so VCs from inception, there is a lot things that is getting planned. I think one more speaker is on the way. I think we have to just wait for him, and he will be out there, and he will come. So by then, I think any questions, folks? Like, if you have any questions, no, fine. So in the meanwhile, let me just call that person so that we can just get the thing sorted out. It's the Bangalore traffic, man. We can't help anymore. It's going to take its own time to reach any place. I can't help that. Uh, Wait. Hey, is there a message on my?
Yeah, yeah. This one.
There's one message. One second, folks. We are just taking a small break, so we'll be back. So, hey folks, we are back now with another speaker, Shadab Hussain, and he'll be talking on AWS and MLOps. And over to you, my friend. The stage is yours, and share your screen so that we can get it started. By the way, he's not turning on his camera. Don't worry about it. He's a human being teaching you. It's not a bot. So don't worry about it. Unmute yourself. Now you speak.
Yeah. Hi.
Yeah, go.
Hey, hi everyone. I'm Shadab and I work as a senior associate MLOps engineer for the map company. So it's been 5 years in the industry. Like I've been working in data science, dev advocacy role and all. And recently I moved to the MLOps. So today I'm going to talk about demystifying MLOps on AWS. A bit more about me, like if you want, I recently got certified for CMLS, AWS CMLS as well, and I'm one of the AWS community builder. And
Can you sit
few of the
down
things
here?
I've not mentioned here.
Can you sit down here and explain because
Okay,
my can't catch.
sure. And I also co-founded one of the community for quantum, like Quantum Computing India, which is not mentioned on the slide, but that also I'm running for the people who are interested in quantum things. And if you want to connect with me on LinkedIn, Twitter, Instagram, Facebook, GitHub, wherever, this is my handle. So we can connect over there. So let's get started for today. So the agenda will be we will start with the introduction of. Introduction has already been covered by Raghavendra and Vishwas, I, and they would have covered obviously very much in detail. So I will just touch base on a few of the points, and then we will go to the AWS setup, and we will see like how different AWS services can be used for building MLOps pipeline end to end. So they will be like we'll be doing I have already done the environment setup. We will just go through it, and then we will look at like how we can configure the CI/CD pipeline, like setting up the bucket and code. Data repository, then configuring the pipeline assets, and also like how we can build and execute those pipeline online. And once the CI/CD pipeline has been built, then how we can like test that in development environment based on certain threshold, how we can put that in the production, and so on. Okay. Yeah. So just a normal question to you all, like if you are working as a data scientist, or if you are working as a data analyst or machine learning engineer, so earlier we would have seen like the timeline to put a POC to the production was very high, right? It was not that easy that once we have trained the model locally, we can just like build a pipeline and get it deployed. Many custom tools were getting used, like Airflow, then Jenkins for CI/CD pipeline. We have to make sure the whatever credentials we are using, those are being configured properly through the configuration files and all, right. And data security was also the one of the things, so that there's no data breach. So there comes the data security and governance part. So if I just ask a normal question to you all, like generally how much time it takes for you or for the organization or for the project you have worked on to, like, even if a small change you're making in your code, right, how much time it takes for you guys to put that in the production?
5 minutes.
Now
Yes.
for the few days easily, right? Because there will be a lot of dependency.
Checks and lot of authorization and all that.
Yeah.
Yes, authorization checks. Then you have to make sure you have to rely on DevOps engineer there. Like if he's not available or if he's not doing the work on time, then your whole deployment will be pushed for few days. So
Jira tickets manipulated.
yeah, so these are like few of the constants over there. Next thing is like after deploying the model as well, right? Once the model is in the production, it's not very easy to monitor for data drift, model drift, whether the data you're getting, it is all the checks are being done for that or not, or there are any drifts in that data, like any values has been changed from A to X, B to Y. So how you will track those changes for the data, right? And also if there are, I mean, once the model has been deployed, it's not like the performance of the model will always remain the same for years. Slowly or gradually it will start drifting, right? So how you will monitor those data drift, model drift and all? I mean, or is your organization taking those constants in count also or not? If not, then you should think of that, because these are the major challenges when you're putting up some data science project or machine learning project, projects in production. Next thing is I mean, once these all we have figured out, right? Another question we can think of, once we have, can we build, test, and deploy these models in a in a repeatable, reliable, and automated way, so that there's less human intervention. More of the things we have automated. Just when something is going wrong, we can trigger the notification via Slack or Teams, and we get notified like some action we have to take. Or if some pipeline is getting failed, we can get notified for that, and we can manually go and check and approve or pause that deployment over there. So,
Definitely quite fast for a minute.
yeah.
In the previous slide, you talked about like kind of production.
Hmm.
Once you deploy the model, you talk about like model deploy data drift, right? So we need to continuously monitor it.
Yes.
So what I mean, how can you talk about more on that perspective? How do we do that? And
Yes, I will be coming to that. So model, there are like you have to decide certain checks for data and model, and you have to write. So for each of the projects, right, it's not like it's going to be fixed check for data. If I talk about, then one of the example I can give you for one column. Let's say I am getting some temperatures, right? Earlier last week, suppose my pipeline has been scheduled to run on the weekly basis, right? Then last week I got the data in Celsius. Now there has been some change in the business logic, and because of that, the unit of those temperature column has been changed to Kelvin, right?
so that those are the standard checkups based on the values you can check.
Huh,
Other
but
than that, like, is there a more of a column values check which we do it?
yes. So this is just an example I'm giving you. Apart from that, you can check out, because you cannot train the model. Suppose we need to monitor for normal. If a certain column is normally distributed, then only we are moving further with the next step. So monitoring the normal distribution is the another step. You can get the data, you can check for the normal distribution of that particular column, and based on that, either you can move forward or you can stop the pipeline there itself, right, and trigger the notification.
Again, that varies from column to column.
Yeah, that will vary from column to column.
Continuous values versus free text versus predefined text.
Yes, that will vary.
Will be keep varying.
Yeah,
So if you talk in high level that perspective,
yes.
can you? I mean, you talk about any tool as such for this activity, or how we need to write our own customization or MLOps cells in that is what I want.
So there are tools as well for monitoring data drift. Like I think Selden is one of the tool, like which is handling end-to-end MLOps. But those tools are paid one. Like at enterprise level, they are available. Apart from that, there are many other tools as well. I can give you the.
Open source. Can you talk more?
For open source, I don't remember. For open source, I remember the data versioning tools, because data versioning is also one of the DVC is there for that.
But
And
like, let's say, let me be very frank with you, it depends on your schema that you're architecting towards it.
very customized,
customized,
it should
bro.
be for the project and model.
Let's say you're a SaaS company and you're taking all the code into one place and you're testing it out and you want to train a model which just detects magically and mystically that this is an anti-pattern that's happening and things like that. No, don't worry, it just happens. It's just wind or something that everybody is so worried. But yeah, like I'll say what's happening here. You're basically playing with the schema out there. That's what you're doing. You're basically targeting ingestion layer. You're not targeting anything beyond that. Because data ingestion has to be proper in order to get that model trained. Like egress, ingress, all these strategies, right? It's all there for you. So you need to rightly strategize that. But if you want more of an open source tools, I can say Linux Foundation has a lot of ML tools it is getting nurtured in that foundation. So just go there. Linux Foundation has a lot of solution for you. Just type in machine learning, boom, you get everything in Linux Foundation.
Yeah, and there's a website where I can list you all. I mean, all the MLOps tools are being listed over there, and they are being categorized for different components. Maybe like after the slides, I will share with you all. You can like just filter out for different components and have a look. And they have tagged that as paid, open source. All the customization and things we need to look at, they have
Okay, simple
given
trick. If you
the
are a
details.
cybersecurity expert, just do Google dorking. That's it. That's it.
Yeah,
Just type in data versioning, file type, LIDOS or something. It will be there
you
for
will
you.
get it. Yeah.
That's how we
So
also learned.
yeah, coming back to this question, right? It's not very easy, right? If we go the traditional way, like how, even if I go back 1 year, right? People were using Airflow DAGs, they were spinning up the clusters manually. Few company ended up writing their own custom packages using Google. If you are working on Google Cloud or AWS, right? They started using their own their SDK, and they started building custom Python packages based on the requirement or based on the things they were doing, so that the spinning up of the clusters, the allocation of the resources can be taken care of. Then Terraform, CloudFormation, all these tools came in, and people slowly started using that for spinning up the infra part at least, right? And still for testing and deployment, for deployment, people were using Airflow tools, and for Airflow also they needed to configure the whole infra there for Datadog clusters and everything, right? So it was not very easy earlier. It's not easy. I will not say it's easy, but if end-to-end MLOps, if lifecycle, if I talk about, right, most of the things can be automated. And if I talk from the starting of the machine learning lifecycle, like the ETL pipeline, which was earlier taken care by the data engineer, and there was a high uh, dependency on those people, because if they're not providing the data, if they're not doing all the check for the data scientist was not able to move forward. But once these MLOps components started getting integrated with one another, right? The ETL pipeline, the check for those also can be taken care by the machine learning engineer or data scientist itself, because as an MLOps engineer, the MLOps engineers, they write the code for the pipeline, and in those pipeline modules, the code of the data scientist gets imported. So they are building, basically MLOps engineers these days are building a framework sort of thing, so that the life of data scientists and machine learning engineers can be eased off, right? So whatever changes they want to make, they are making, and the time to pull the data, raw data, dump that to some bucket or to database, train the model, put that in the production after doing certain tests, system test and unit test and integration test. These three type of tests are being oftenly used in the industry. Apart from that, there are multiple other test types of test as well, but that depends upon the sort of application you have built for your project. So if you build some sort of web app, right, to deploy that model, so those testing thing will be different. So earlier it was not like that, but now the things are moving on the faster pace, right? So with the help of MLOps, we can like by using the CI/CD pipeline, we can bring improvisation in those things, and the pipeline which we're getting at least 2 days, 3 days of time to get deployed in the production earlier after getting certain approvals and checks can be deployed automatically, and we just need to monitor and set up certain threshold and functions to get notified if something is going wrong in the pipeline. And even the infrastructure part can be automated. Today I'm going to talk about AWS infrastructure, right? So we are making use of cloud formation over there, in which we have defined all the components, all the resources, even IAM roles and all we are creating in the using the cloud formation script itself. Deployment also I'm doing on AWS CI/CD pipeline, like code build, code commit. We have even for storing the for running the pipeline also we have code pipeline there. So end to end, all the AWS services are getting used. We don't even have to move outside the AWS infrastructure. Moving forward, so this is the rough architecture. This pic has been taken from the AWS blog only. So as a data scientist, we end up using SageMaker, right? That is preferred tool for us. We load the data there. The data source can be S3 bucket or some database. It can be RDS or wherever the data has been stored. Then we have code commit, where we log the model assets, whatever we have. We have code pipeline, using which we divide the whole flow in certain stages. It can be build, it can be ETL stage, it can be train stage, then development, dev environment stage, then testing stage. Once the testing has passed, then we go ahead and move, put that model in the production. So all these stages, once we spin up the cloud formation script, right? Then this code pipeline, whatever pipeline we have built, that will be triggered, and all the stages can be monitored. Like when we go to the code pipeline, we can see the execution, what is happening, what is failing, and all the logs can also be monitored from there. And for each of those uh, like stages of the MLOps machine learning life cycle, right? We can monitor certain metrics if there are any. Like for the ETL, if we are performing certain checks, we can check at the values, like what values we are getting over there. For after model training, suppose if I'm checking for certain metrics for the model, we can go to the training stage and we can check for those metrics that will be getting logged. And then we have code build for training. So code build is basically used there. We will be using inference container. After the model has been trained, we will make use of that for making the prediction and see what values we are getting from the model, right? And using or developing these MLOps lifecycle end to end on any of these particular cloud infra, one benefit we have is like we make the predictions. Even though if we are making use of all the open source tools, right? You will make the prediction. You will make use of the prediction however you want, but you will not. Most of the people leave that part. I have seen in different projects that they don't keep the log of the predictions, like what was the input, and for that input what output I got, so that basically those input and output combination can be used for the model further, for improving the efficiency of the model. With that, right, we will have some new data which can be ingested in for retraining the model, and model accuracy will be improvised with new data itself. So the model drifting, which can be faster if we are not considering the retraining the model, will be like not going down like very soon. It will take some time because we are considering the retraining part here also. So this is the rough architecture. So there are four components which we are going to talk about. First one is like configure the MLOps CI/CD pipeline and source data repository. So let me get out of this. And yeah,
It uses the AWS DevOps tool set, right?
yeah, everything like we are using DevOps here. Yeah. So if you don't have AWS account of your own, like you can just create one and you will get $300 credits. And once you have those credit, you can just log in into your environment and you go to Cloud9. There we will create an environment with whatever name you want to give. And after that, the machine, since there's a lot of like, we are not just going to train the model here, like what info we are going to see. We will be also simulating the load on the trained model to monitor like how the auto scaling has been taken care of and how the number of instances are increasing. So we are choosing T3 large EC2 instance here, and one IAM role we will create, which will be used in the Cloud9 environment for triggering the cloud formation script to spin up the whole infra. So the new this IAM role which we will be creating will have the admin access of all the AWS resources.
A quick question. So, just conceptually, I just want to understand what is the difference between when you say there are different terms coming up, basically data ops, and then you are having MLOps.
Yeah.
So, how do you see the difference between these? Often, people get confused. Even I get confused sometimes. The
Yes.
data ops and the MLOps.
Yeah.
How do you see it?
So the three different terms, and wherever the infra operations are being involved, right? People are conquering new words there. So they will make up DevOps, they will make up data ops, they will make up MLOps. Now DevSecOps for security folks, right? Even in MLOps, we are considering DevSecOps also now to be one of the components because of no DevSecOps. Yeah, someone will conquer that term as MLSecOps. So if we go that way, right, DataSecOps will be more limited to the ETL pipeline.
Okay.
Okay, so whatever ETL, whatever you're doing, data pulling from some raw resources, right? Transformation of that, dumping that to some source, that will be like data ops. MLOps is like end to end. It's not data ops. You can consider as one part of the MLOps.
So we can call ETL engineers as data.
ETL is basically the data ops here, And MLOps like is the big hub.
So
where-
DataOps is a subset of MLOps.
in not in all the cases, there can be a project, right, which is just limited to data ops, and then it's getting used to the application directly. There is no ML involved there. So you can treat data ops as a separate component, but it can be the part of ML ops if you're building some ML ops projects. If ETL pipeline is involved there. If in MLOps, so in MLOps also, it's not like everyone considers the ETL pipeline also in the architecture. Few people keep their ETL pipeline separate also, right? So data ops will be separate, then MLOps will be separate. So there are different scenarios over there.
If a semantic layer is being built on top of the production data set, basically that's a data ops.
Data ops,
So,
yeah.
to easily summarize, it's like you have separate tables, semantic tables, flat tables on top of your raw data set. That is what data ops is. Like I have been working on that, area, so I can comment more on that. And like ML ops is more towards machine learning models in production. So these are two different things, no? So your data layer, which analyst or the reporting consumes, is more towards data ops. Like,
All right.
So same as DevOps, right?
Yeah.
DevOps also doesn't take care of data.
How?
So it doesn't take
Data ops
care
is
of-
always separate.
Always separate, yeah.
Application consumes the data. So same way machine learning needs the sanitized data.
Okay, so after that we'll create the environment, and just to check on, we will execute this command to check like who is the root user in the environment. Okay.
I have one question.
Yeah.
So this model will be in production, and anyone can call this model like that. It will be like that. Whatever we are going to have the demo on. So this pipeline that you see, it will have an end result as a model in the production.
Yes, endpoint will be there, and we will simulate some load on that. So there's a script for that as well. Everything I put on the GitHub. So if you want to try your hands on, I can share this whole project Notion link and follow the step and pull the Git code, and you can simulate the whole like work this tutorial part on your own AWS environment as well.
I'll share in the mailer, don't worry.
So it will be shared for your practice. If you get stuck somewhere, just ping me. There are certain challenges which I also faced. I will highlight like
Even the data ops should have an unstructured, structured data format as well as an input to the data ops.
it's data ops. I'm not sure about that. Like
The point is that the machine learning model should be able to consume the data.
yeah,
So that is prerequisite to MLOps.
no,
Data
it's
is
not like
ready.
that.
Then what will the ML model train on?
So so in ML ops, there are different components, right? Data ingestion. Then once we get the raw data from some source, let's say Snowflake is my source of the data, right? I will pull the data, whatever transformation, cleaning, pre-processing I have to do, I will perform. Then I will dump that to some storage. Now that will be my source of data for my model.
Correct.
So that will be taken care by the data pipeline. Now, once that data has been stored, few people what they do is they directly before dumping the data, like after getting the raw data, they directly create the features what they need to ingest in the model. They dump that. Few people what they do is they dump the data in different stages. Get the raw data, dump that as an intermediate data. Then load the intermediate data, process, do the feature engineering, whatever you want to do, then dump that as a feature store. So feature store is also one of the concept in MLOps, which so feature stores are those is it's also data set, and this also needs to be versioned. Like as we version the data, so feature stores are also versioned, and feature stores will be directly your input for different models. So feature store we just don't maintain for one model. So suppose if 10 data scientists are working on 10 different projects, they can make use of the same feature store. So there will be a data pipeline which will pull the data, which will transform, pre-process, whatever we have to do. It will create the features and it will dump to some storage. Now 10 different data scientists will be loading the data from feature store based on their need, whatever feature they need, and they will ingest in their model.
At the same time, in case if the data pipeline fails,
Hmm.
how to track it?
Yeah, so for that, if any of the pipelines are getting failed, right, we can configure the notification. So all the cloud services have that capability built already. And using those notification, whatever we are going to trigger, we can send the notification to the most used channels like Slack or Teams, whatever people are using there, right? And they get notified immediately. We can configure the notification to be sent on through email as well. Even though if there's some morning, right, model drifting will not happen overnight. It will happen gradually. So you can set certain threshold, and based on that threshold, at certain stage you can trigger the warning. At certain stage you can fail the pipeline. Based on that, you can take the call.
Hello.
So, Shadab, in AWS context, the monitoring of the model and all will be done by CloudWatch.
Not just CloudWatch. Actually, CloudWatch. Actually, we are
CloudWatch
using.
is the only
Yeah.
monitoring tool inside.
Yes. CloudWatch we are using, and in that you can select custom ways to monitor that.
Threshold and all you need to set.
Yes. Let me log in. My account is logged out. It seems. So for these kind of tutorials, like I have to repeat certain tasks a number of times.
You have to automate those.
Yeah, automate. Sometimes it will fail. You have to repeat the whole step from the scratch, clean up the infra, everything. Yeah. Coming back to this, right? Once we have the environment created, you will see an EC2 instance created because we selected T2 large machine. And the role has also been created with admin access, and we will allow, I mean, this is the role creation part basically. We are creating an IAM role here.
Okay, this is giving the UI screenshots, right?
Yeah, this is just to understand. Then
The
we have a
process.
cloud formation
The
script.
formation template does everything.
Everything will be done automatically.
Automated.
Yeah. So this is just for the understanding,
Right.
like how and what is happening. And yeah, so once these all things are done, we will configure the we are configuring the newly created IAM role on the Cloud9 environment. And again, when we will run, so instead of root user, the new IAM role what I have created, I will get to see here.
Just like a service principle as in Azure, which authenticates.
Yeah, you cannot make use of root user for
Non-root user.
non-root user should be used for cloud formation script. Yeah. Then once this things has been done, then we are setting up certain environment variable here, like default region and account ID, ARN role, data bucket, and pipeline bucket. So these all are the default variables we have set over here. And we're installing the required packages, Python libraries, whatever we need. And this is the repo where I have kept the code. So I'm just cloning from my Git. So data is also available there. We are making use of Avalon dataset. If you don't know, like you can just Google and you can check it out. And once that has been done, so we will be running this script over here for EBS, like attaching one extra storage volume, so that if there's a problem with storage, how it can be like handled. So we are scaling up the attached storage of EC2 instance. And so when you will run this shell script, right, you might can run into the issue of like permission denied. So just allow the permission of executable, and then you can run this again. If you don't get this, then you can directly run this command. After that, yeah, so once this has been done, right, next is configure pipeline. So in this, we will set up the S3 bucket where we will like dump the data at different stages. And once we have deployed the pipeline in production or in development environment, right, whatever logs, data logs, prediction inferences will be getting generated, that will be dumped in on the S3 bucket. We are not like storing anywhere else. So let me show you S3 bucket as well. Here. And there will be code repository also, which we will be setting up here. So data, you can see, right? So data part is basically for data dumping, and raw data will be read from here. And MLOps, this bucket which you are seeing, will be dumping the data and predictions inferences from the pipeline when it will be triggered. So if I go to this data US, so I'm using US West 2 region here. You can see input reports also, whatever will be getting generated for the data, right, will be getting logged here. So this is the monitoring schedule. And so I don't have enough time to explain the code in depth, but stats, constants, whatever you have configured will be getting dumped in the format of report here. So if I have to look at certain stats, right, let me download this file actually. So you can see, right, the uh, whatever stats I've generated for the given data set has been logged here, like lower bound, upper bound, count. Then this is for the distribution. So you're asking, right, data drift, and also these kind of statistical checks we need to do for monitoring the data drift. And based on like use case to use case, it will be differing. It's not like fixed thing.
How versioning will be maintained? Because I'll be continuously, training assume that by changing the data.
Versioning can also be taken care.
Versioning is there, but I wanted to compare at the same time, like previous one versus current run.
Yeah. So
to
for
make a difference, right? So
Huh.
with respect to the detailed levels of the statistics which we generated, is there any way?
Yes. So I have not like taken care of. I mean, it can be done on AWS as well, but I have not taken care for this tutorial. But another easy way which will be there is like to make use of weight and bias, Neptune or MLflow tool. MLflow is the open version. As you log like model parameters and metrics, right? The same way you can log the data metrics as well. So for each pipeline run, you can do the versioning, and on so MLflow server will be separate, right? You can go on that UI and monitor the data, like stats, whatever is getting generated. Same way you can select the model and can monitor the model stats as well from there. So you need to integrate MLflow, and it's easy to integrate. It's like you just have to make it run on some EC2 machine and make use of that in the code. So yeah, that can be taken care of on AWS also. Like
So when you show the buckets, right, is that some tabular form than any other AWS service? Like let's say GCP or something arbitrary.
yeah.
So something like that in AWS.
So on AWS, I mean, I've not used, but S3 can be used as the source over there. Like, so if you see the structure of this bucket, right? Date, then different run, and then different.
Yeah, so here I have to go to the bucket, right? Let's say I want to give a tabular view. So just write a SQL query and fetch the data.
You can do that from S3, right? I mean, you can make the use of. I mean, you can read these files, and so basically for that also you need to build a separate pipeline. Right now, like in this tutorial, I've not done that, but this can be done. Like if you want to dump the data to RDS instead of S3. So at the configuration stage itself, don't make the data dumping source as S3. Instead, dump that to the RDS along with the date, version run, commit ID. Metric will be the columns and the values you can dump for each of the columns. Then so you can do that.
RDS is relational.
Yes.
So you want relational.
Relational.
And RDS.
Then RDS you can make use of. But here we have not used the structured one. We have used S3.
So you can also dump it to both the.
You can do.
Somebody
Yes.
want to do
Yes.
that.
Yes. You can do that. Okay. So yeah. So this is how it will look like. Moving forward. So S3 bucket, data bucket will configure for data and data related stats. And so this is the URL from where we are fetching the file. You can get it available online as well. And here you can see, right, versioning you were asking about. So this is how we are putting up the bucket versioning also for this data bucket.
But when you talk about versioning, right, the folder structure and all which is created will be dynamic. I mean,
It will be dynamic, will be taken care by the AWS services.
AWS.
Yeah. So you have to just configure that, and based on that, it will be version. So whenever some new data is coming and some change is there in the raw data, new version will be created for that. On Azure, it's been taken care separately. Suppose if this week you had 1 million records, next week you have 1.5 million records. So if you have version based on the date, so till let's say till 11th November you had 1 million record. Then from 12th November to 18th November, additional 0.5 million record came. So those 5 million record, 0.5 million record will be dumped as the version 2. And like that it will so, and it also depends upon like what configuration techniques you're adapting, incremental, or you're just updating the whole data by taking that, right? So it depends upon that as well. Then we will configure the ETL data bucket as well, and code commit repository we will create where so whatever code we will clone on the Cloud9 environment, right, those will be available on the Cloud9 environment. But one repository we are creating using AWS code commit service. And so what will happen over here, right? So suppose you have different things to do, like ETL pipeline, you don't want to test if you have to just test some ETL pipeline and you have not done changes to other components, it doesn't make sense, right, to run the whole pipeline. Does it? Like, who is going to run the whole pipeline if I've just made certain changes to the data pipeline? It should not be like that, right? So you can do the branching on AWS code commit itself on the newly created repository, and whatever component you have made changes to, you want to make sure, because it's not like once we have coded and once we have automated this stuff, we need not to do anything over there, right? It should be monitored. So if some changes are being done, so instead of deploying the whole pipeline, you can just go to the ETL pipeline where your data pipeline code has been updated. You just execute that and monitor whether that pipeline is being getting triggered properly and running successfully or not. Then push that to the main branch. So like that, it goes for ETL. Like that, it goes for model training. And then it goes for deployment as well. So that is one use of code commit. Apart from that, like using AWS code commit, the whole updated code will be there, and you can trigger the pipeline from this. Okay, so these are the certain commands we have run for this, and then we are creating a container image repository. So Elastic Container we will be creating over here, where we will be like which will be used as the inference container for making the predictions. Then once all this has been done, so once the environment creation has been done, right, ETL has been taken care of, code repository has been taken care of, and instance container has also been taken care of. There is a validation script which will check for whether all the three things are being, whatever checks we want to do, right? You can write these kind of code as well, whether what stages has been done successfully, and if at any stage any of the things are failing, then what are those components which are failing and I need to look at manually. So those validation script you can run and you will get the summary, whatever, however you code that. Here I've just like printed the message if it is being configured properly, and you will get, if suppose data repository is not being validated right, then you will get the reason why it has not been done, and whatever so reason is, and you can go and check the code or do certain checks based on your understanding and make it fix. So after that, so if I have to summarize that, right, at this stage, we are creating the S3 bucket, configuring that for data and data versioning and all. And we are creating the code commit repository on AWS, and we are configuring the container for inference. Next is the configuring the MLOps CI/CD pipeline assets, right? Then in this, if you read here, right, so we will make use of code commit and code build to store the, like, whatever automation we are doing, right? Those components will be stored at this stage, and before like they are being pushed to the pipeline online, right? Before all the stages, we are making sure that this is the final version what we want to get deployed. It's always recommended that we test those functions, those model training locally. Like if you're working as a data scientist, it's obvious, like we will first test everything in our notebook. Then we convert that to the Python script or deploy that as a notebook, whatever way you want to deploy that, and put that in the main repo for the pipeline. So there are certain steps involved in this as well. So in configuring pipeline, if I have to talk about, right, let me show you a few more things here.
No, I was thinking there was connection, right? I was like, why are you configuring minutes? Hey, there is Boto demo, right? Okay, awesome.
It's taking some time. Why? Yeah, so you can see, right, MLOps repository code commit repository we created. So you can see here, if you go here, all the details you can check. We have configured that for HTTPS connection as well, so that you are able to make use of that. Further, whatever files I have, so there are different branches I have created for this, and app.py file is there, and Nginx configuration we are doing, and model assets what we are talking about. These are being kept in this folder.
These are artifacts, right? Like after training.
This is the repository, code
Oh,
repository.
code repository.
So there are different environments, dev and prod. So like that, if you have some QA environment as well, you can create a new folder for that and put the code in that for QA. Moving forward, so I don't consider myself as a AWS expert. I'm still learning, to be honest.
These are
So
all too many changes.
Nobody's judging you.
Nobody's
No, nobody's judging you. Don't worry.
By the time you feel that you're expert, this is not ready.
yes, so I'm never
No,
confident.
even if you think at the phase in which every Ignite comes with new services, every AWS reinvent comes with new services. Like Firecracker, I didn't expect a VM on a serverless concept, and they bought VM on a serverless concept. I'm like, where did they get all this idea? And
So
every white paper is something huge in AWS. Every white paper, I feel I'm outdated.
That's fine. Once you get on a project, then again you start reading and
Yeah.
can't keep track of 500.
Oh yeah, that's true.
You need an AI engineer for that.
Yeah.
okay, so let's get back to this. So in the second component, right? So I have divided the whole tutorial into 4 different steps. So these are the 4 steps. Let me show you here itself. Configuring pipeline data repositories, pipeline assets, executing the pipeline, and once the pipeline has been executed, while executing, there will be different stages, which we will just have a look at what is happening at different stage, how the automatic approval has been taken care of. For ETL pipeline, we are making use of AWS Glue. So there's just one job running over there. And then we have the like how we can manage the production deployment and what are the things and constants we need to take care of. So this is like divided into 4 steps. Here, if you see in ETL job file, we are splitting the data. We convert the ring feature. Some pre-processing we are doing over here. And there's a configuration file which contains the Glue Python shell job configuration. So this will be used for triggering the Glue, creating and triggering the Glue services. Then we have model training files. So in this pipeline, we whatever code we have modularized in different components, right? So ETL was one, training is another one, where we are taking care of model training. We are taking care of deploying that model to the endpoint, like serving that model as an API. So API gateway is getting used over there. Then for configuration, we have nginx.configuration, from where the server configuration will be read and it will be configured. We have a Docker file that contains the command to assemble the container image. And then we have build file, which will be staging the like it will be different for dev and production. Based on that, we can make call of that. Apart from that, what else we have here? And then again, like testing is also the important essential part. You should not, even though like testing earlier at earlier stage in data science project was not very important, but these days it is essential, and you should definitely set unit test for your code, system test, and integration test for the whole pipeline whatever you're building, so that you are aware of what is happening and what logics you need to, or what test cases you need to consider before putting that in the production. So these are the 3 different pipeline components. Next is creating and executing the pipeline, right? So here is the main architecture of that, like how the flow looked like. So code build is, let's go this way. Right. Once the code has been, no, not from here. Yeah. So code build is here, right? So I mean, code pipeline is here. So from the code pipeline, we will like once everything has been done, then like after module training, the inference part will come, and there we will be making use of container registry. At code pipeline step, we will use a lambda function for spinning up a serverless resource for running the ETL job. Same we are doing for model training as well. Lambda we are using for training. Code pipeline, whatever logs are getting generated, right, at each of these stage, not just for the model training, can be monitored using CloudWatch event. Then using the code pipeline, we will deploy the whole code to the dev environment or QA environment, whatever we have. Once it is being deployed to the dev environment, after that, we will do the system testing and we will check for all the thresholds, whatever we have configured for our code. If all the tests will be passed completely, then only it will go for the production environment. At any stage, if that test will fail or if something is going wrong, some pipeline is getting failed, it will not transition to the next stage. So you can consider these as a stages. ETL is the one stage, training is another stage, then dev putting the model to the putting the pipeline to the dev environment is another one, and putting the whole thing to the production is another stage. So if I talk about creating the pipeline, right? So again, certain configuration we need to do because the whole thing we are going to run through CloudFormation. And let me take you to the CloudFormation console directly from here.
So CloudFormation is a scheduler.
CloudFormation is, have you heard of Terraform?
Yeah.
So it's similar to the Terraform where you, so it's an infrastructure as a service. So you write the script over there, commands, whatever you have to execute, and it will spin up the whole infrastructure.
It's infrastructure as a code only. It's not infrastructure.
Yeah, as a
VMs
code.
become the infrastructure.
Yeah,
as a
infrastructure as a code.
Provisioning, it's a provisioning.
It's a resource allocation.
Right.
That's it.
But
Without using the UI.
yeah, but how do we, you want to run the pipeline at a setup scheduling, right? So how do you can set that? Is there a
So
is
once-
like Airflow we have, how we orchestrate the whole flow?
So on AWS, we have services to schedule the pipeline as well, so that it can be triggered on whatever periods we decide for that.
Okay.
So in this, I have not considered the scheduling part, but CloudFormation we have done. If you want, we can take a look at that as well further. So let me open the Cloud console over here. So once everything has been done, right, and you run your CloudFormation script, then first it will build the Avalon pipeline. Like this is the data set and this is the pipeline name I have given. If we go to this pipeline, there are certain events which are happening, like creating creating monitoring event for different stages, creating user, creating the pipeline, right? So all these things will be happening and you can look at the progress of each of these events. Once everything has been completed, it will be marked as creation complete. If anything will fail at any stage, so this pipeline script are being written in such a way that it can roll back all the spinning up of the resources allocation, whatever you have done, so that if something is being stuck in the middle, right, it will be difficult for us to go and delete the resources or make changes to the infrastructure manually. So the rollback configuration is there, using which all the things happened previously will be.
It has the auto scaling feature.
Auto scaling feature is also
I
there.
mean, auto upscaling and downscaling.
Both. So once the model is in the production, it is essential for us to take care of the load what we are going to get for the model. So you can decide the minimum number of instances, maximum number of instances, and once your count of instances is getting to the maximum, trigger some notifications for that too, so that we are getting max load now, what to do next, so that some DevOps guy can come in and take care of that too. And
where does the flow runs in? Like the flow is run on a Kubernetes cluster, or how does it?
Either EC2
EC2 instances. So containers basically we have on AWS, right? So we are making use of that. So
This will be in serverless.
few components are running on serverless. Wherever we need to spin up the instance, we are spinning up the instances. So it's mix of all the resources for different services.
Basically, that serverless aspect is just for the cost cutting. You can't keep running T3 instances
Yeah.
for a very long time. T3 instances cost a lot. And if you think of the scale which Hotstar and all are working, C5 and X large machines, right? That's very costly and they can't have cost coming up from AWS. So that's where serverless aspects
This is
happen.
only for the max time.
Max time.
Next.
Once it's over, they're back to.
They're back to
Yeah. So
the
one EC2 instance will be there up and running for this pipeline. Okay, and all the resource allocation for running the different components will be spinning up and getting destroyed once the job is done. Like in normal terms, if I have to talk about that. So you can see, right, train launch job, ETL job monitor, then
So you are saying on a temporary basis they will be.
that's how we should use the resources, right? Or if we will end up resourcing using the resources for any limitation to that, the cost will be very high. So as a solution architect, like if you're working for the team,
Just like pay as you go.
yeah, pay as you go. So not all the services will be pay as you go or pay as you use. I mean, pay as you go, all the services are like that,
Right.
but pay as you use is just Lambda server. Yeah, so Lambda server will be also making use of different services, but it will destroy after the use. It will not be up and running always. So yeah, so this is like for the main pipeline. Then once this pipeline has been done, then we go to the dev environment. The different events happening in that, like model, endpoint configuration, then creating the endpoint, all these stuffs. Then once this is done, then after that system test. So there are four stages I talked about, right? First the main pipeline, then dev environment, test environment, then the production environment. And thus after that, once everything has been done, we will go to the production environment and we will look at what has happened. So let's have a look at a few more components over here. Yeah. So when we execute the pipeline, right? So these are the stages which pipeline goes through. It's not like you have to do each and everything, or these are the only stages. You can define this based on your own, like project based on your own logic, whatever you want. Like, but overall, like if I have to generalize, so these can be the stages which I can think of. Obviously, like QA, as you see, I've not put it here, right? Or system or test, you can. This is stage basically executing automated system test. You can consider that as a QA environment where we are making certain checks before putting that to the production. So source stage, build stage, and all these are there. So let's see these stages from here. Code pipeline, I need to go ahead, right?
This is amazing, man.
Too good. The entire
Too good.
flow is clear.
I remember one of my freelance project which had torn up, and the CEO all of a sudden called me, which was the pipelines which you have done is already broken. I'm like, sir, मैं अभी party mood में हूँ, sir. Sorry for that.
So these days, basically, I'm focusing on building the framework, not just making use of it on different cloud, like cloud, GCP, AWS, and Azure. Once we have the framework ready, right, it's more of like plug and play, and with little or no change, any data scientist can use that for their project.
Seamless integration across.
Seamless
all
integration
platforms.
across all the projects.
See, like it's just API token that you access. That's it.
So this is where the MLOps engineer comes in, like to ease the life of data scientists and data engineers. So yeah, I was talking about different stages, right? So this pipeline has successfully run. I mean, we cannot go for the live demo here, but I just did in the morning. You can see the timestamp some 10 hours ago.
10 hours ago.
Morning.
I didn't sleep actually.
Yeah, don't worry. I
So
also.
there are different source you can see, right? Data source, test source, ETL source, model source. So suppose at data stage for ETL, what will be the requirement? Anyone tell
Extend,
me?
transform, and loading.
That's the action what it's going to take. What's the prerequisite for that? Data is the prerequisite, right? So and this
Schema, like proper schema has to be proper.
metadata and
Metadata,
data,
yeah.
whatever is getting used, data basically will conquer everything.
Conquer.
So if data is missing there, data source will fail, right? So my data source is Amazon S3. Suppose before running this pipeline, I have not uploaded my data to the data folder on S3 bucket, right? Data bucket, whatever I've defined there. Then this pipeline will not run and it will fail over here itself.
One primary question, it has to sense the data is there or not.
Yes.
How frequently you retrain the model or deploy in the product?
It automatically sends. Once these pipelines are being built, right? Either you can schedule that, But for this whole flow, what I have created, it will automatically sense if a new data has been updated or if there is any change in any of the pipeline components. Like if you have made some code changes in the ETL or if you have made some changes to the model code, it will be automatically triggering the pipeline and running the whole execution.
So there has to be some criteria, no, beyond which we have to retrain the model.
Huh,
If there is
that-
one line item in the data source only, we cannot
Don't
retrain the
commit
model.
it to the
So there has
main
to be
branch.
some- yeah.
No,
Like
it depends
work.
on your use case also. Like whatever you're asking, let's say I'm an voice assistant company and I receive data every single day, and I have made sure that my strategy is 1 week once training.
Yeah.
Every 1 week once I'll train the model once the data is in.
Yeah.
Also I've strategized it
Scheduler
as 1 day
basically is
one,
used there.
1 day once, every day 4 a.m. in the morning it has to get trained because the data workloads are very less on the cloud, so I'll be easily available. So that's what I'll be strategizing. Like whatever I showed in Databricks and the mailer that I got, that amount of mailer, I had scheduled it for every half an hour. Just go run, run, run.
Yeah.
That's the thing.
So
Every error
scheduler
message
are
is
basically
changing.
getting used over there, okay?
Yeah,
And
that's it.
more of like if you don't want to trigger the pipeline, if any changes are happening in the code, that also like you can exclude continuous development.
Continuous development.
We just exclude from the pipeline.
That's it.
So it will not be triggered if you're making some changes to the code. It will be only triggered on the schedule time.
So here we have also, how do we enable the alert? I mean,
Yeah, notify you can see here, right? So you can create notification rules based on that, like alerts can be
do we do
configured.
SMS or receive that?
Yeah,
Email,
email. I think SNS is the service name.
Yes.
SMS is the
Ah.
service name for.
Service
But
which
like-
is being used.
But like if it's too costly for you, SNS is costly by the way. So you can use Rocket Chat or else Pager Duty is available. There's
Some other
services like
tool you can
Rundeck.
configure with within your code itself.
Yeah.
Because otherwise, as you said, the pipeline runs for 10 hours. So because anything if it's in the
No, it didn't run for 10 hours.
10
It
hours.
ran 10
No,
hours.
I'm just giving an example.
That's an example, yeah,
Very-
obviously.
I'm just because alert is the major thing. Right?
Yeah, the notification should be sent up.
Yeah.
Morning itself, I faced that issue.
Whatever.
Yeah. Yeah. So morning when I was training this pipeline, right? So what I did was just for the testing purpose, I disabled the production environment, and till system test stage, I was trying to check my pipeline, what is happening after that. After disabling, I didn't like I went for some manual approval just to mess up with my pipeline, and that approval part was like staged for 1.5 or 1 hour, I think, in the morning. It was which should be approved in just few minutes max, a few seconds. It should not take beyond that. So yeah, you can like
So
trigger the.
human intervention will alter the result.
No, it will not alter. Suppose if I just manually go and approve this pipeline from here, right? Then it will start the flow from here again. Like that it works. So whatever stage you take care of from there, it will be taken care. On like this is like one of the flow I'm talking about, like what I've done. If you
Then it becomes a repetitive task.
yeah, so that's why like once the code is in the production, no manual intervention is there, right? Like, because if again we have to do the task which we have automated manually, then it doesn't make sense of automating the whole flow. If I talk about Google's Vertex AI, right, they're like suppose you have data pipeline, model training pipeline, and all, but in case there are no changes to the data, you just something has gone wrong with the deployment component. So it caches the data pipeline chain component, whatever components you have. It doesn't rerun those components, and it directly run the deployment component. So those kind of cache services are also available on cloud, so that the cost optimization and resource optimization is also there.
The next step it will not rerun from the
It will not rerun from the start. It will just rerun from the step from the component where you have made the changes. So those kind of things are also needs to be like taken care of when you're building these kind of pipelines. So yeah, I was talking about different stages. So you can see source. If anything will be missing, whatever is required for these sources, it will fail here itself. So I tested that for data source. I then uploaded my S3 file and I ran the pipeline. It failed. Then further, once everything is in place, it will go for the build. It will build the image. We will next move to the ETL. So glue job will be triggered here. And that also we are making use of AWS Lambda for running the glue services. Once this job has been completed, then for each of these stages, right, we are taking care of automated way of approval. So whatever drift I was talking about, right, it can be in data, it can be it can be in model, it can be like at least these two stages mainly. So if we are taking all the constant and stats in count from the starting itself, and if we are defining certain rules for auto approval, it will not be approved further if those checks are not being met. It will fail there itself, and you will get notified for that. Then the data scientist, whoever has worked on that, they can go and check for those stats and constants manually and do whatever actions they want to take over there. So the same is for train. Model is trained. If the accuracy is not up to the mark, F1 score is not up to the mark, stop it there. Don't approve and move ahead. And regarding the code commit for each of these sources, so the source act as the code source here. Okay. So you can see the commit ID over here. So you can track the changes. Like for this stage, what was my code version which was being used, right, for this pipeline. So different pipeline runs will be there, and for which pipeline run, what was the code version which was being used. Using this commit ID, you can track off.
At the same time, the model has been encrypted. Right?
Model we are not encrypting over here. Why do we need to encrypt the model? Model needs to be secured, right? It should not be like data needs to be encrypted. Like few companies have those data governance and security issues that you cannot move the data from that particular region. You cannot.
See,
You
why
have
do
to
you
mask the
encrypt
data.
the data is something like, even if it gets compromised, it's not available to them. That's it. Model is like, it has to be available just like that, because if you ask me, I've done black box testing on models which are like 2 gigabytes, and in that you can hack into the system credentials as well. Now, why? Because even if you just go to the TensorFlow, there is a model code, right? Instead of writing it as a one complete chunk of code, just write it as a single code. You'll just get the memory value. That's the RAM leaks which is happening, and that's a security issue at the end of it. Nobody has patched it even today, so it doesn't matter. But if you want it that secure, there is no requirement of encryption of model, but data encryption is a must.
Maybe his point of view is that the machine learning
Model you
copy
can give the same flavor. If I mean, if you're training the model using scikit-learn, TensorFlow, PyTorch, when putting to the production, handling different flavors of model is quite difficult. So ONNX is the open source package which is getting used for converting that model from different flavors to a single flavor which can be put to the production.
Onyx framework.
Onyx, standardization of the model flavors as well.
Onyx is also maintained by NVIDIA, Microsoft, and other companies.
Microsoft.
Yes. So these kind of practices you can take count of. Right?
Especially in .NET, they are using.
No, it's like ML.NET. Yeah.
Okay. So the same goes for train approval. Then we have deployment stage, deployment approval, like build the pipeline and then deploy the model. System test, do build that train and configure whatever test you have to test out. Execute. So these test functions we are executing using AWS step function services over here. Okay. So
Step functions is Lambda.
it is a separate service in
Oh, it's a
AWS.
separate.
It's like a process flow of Lambda.
Yeah.
Yeah, it's
Multiple Lambdas work together.
yeah,
Process flow.
that's what.
It's,
Because in Azure there is durable functions. I get confused with the.
There is a PDF for that as well, where they have tried mapping different
Yeah.
services for different clouds.
Like I get that thing first.
So these will be happening for any of the steps. If you want to check the details or logs, you can just click on the details. You will be taken to a new page where we will get certain options. Let's see what we are going to get here. Yeah, so phase details and all, build logs, whatever logs are getting generated, you can monitor for that execution. Okay.
Question, how do you secure all these things, this pipeline now? Because let's say you're working on a particular IP, which is linked to you, right? Deployed in a client to a particular client. So we don't want to compromise on that.
So those security issues are being taken care by your company cybersecurity team, right? They will give you some IAM role, and you don't have to think much about anyway, if you're on the cloud, right, you will have.
Right? You're not in this scenario which you talked about. Model we are
So we limit the access through VPNs over there, no? Like you restrict the access of the model to a particular IP while inferencing, and no one will be able to access beyond that.
See, critical redundancy checks will obviously keep happening. And guess what? The AWS is not allowing any of your pipeline data to go and sit in the open internet, right?
Yep.
So it's never there. But until and unless you compromise your AWS account through some Terraform push which happened on your GitHub repository where you are already giving your IAM code out there. So until and unless you have an IAM engineer who is working behind who is handling what engine or is critical redundancy checks are happening proper, there's nothing wrong in that pipeline staying in that entire place because this is not on open internet.
Yeah.
So don't worry about that. That's it.
I mean, just make sure your company's environment is secure, your laptop is secure, you're not compromising on your AWS account, and IAM rule, which is getting used for spinning up the cloud formation script, right? That is not compromised. At the initial stage, while setting up the cloud environment itself, I created a separate IAM role with admin access. If you have compromised with that, then obviously there will be some security breach.
Like there are even vaults out there. You can use vaults. That's it. It just makes your entire cloud environment more secure than anything else.
So you can check for the logs, you can check for the phase details, you can like whatever phases were there for that run. You can check for the reports. We don't have any, so it's empty. Environment variables, whatever being used for this run. Build details we will get here. Like what was the VPC environment variable, if any, like all. I mean, I have not gone to that stage of configuration, but you can monitor all the things from here. And resource utilization is also important tab. So if you want to look at the utilization of the resources, whatever was being allocated for this build, you can have a look from here, like how much memory was being used, how much CPU was being utilized. So this is again like important thing to look at for like suppose I'm spinning very large machine and my work can be done with a small machine, a micro a small instance basically, right? Then based on the inference we get from here, we can take the call what sort of machine I should spin up for which component or for which pipeline. So apart from that, so if you go to the execute, this is another thing you can look at. So for each of these approval stages, right, you will also get the logs for them as well. So you can go to that and have a look. So this was a step function, right? For a step function, this was the flow which was being generated. So you can see what is happening, like model is hosted. Then we are evaluating the model. If it is above the quality threshold, whatever we have put, it will go to the production and it will end. And if it is below the quality threshold, what is the suggest balance? I mean, based on that, you can take the call and you can mark it fail also. So these is the, I mean, basically at the step function, we will be doing all those checks before putting the model into the production.
This particular graph is automatically populated.
Automatically generated. Yeah, based on the code and services. Yeah, so that's how, like, if you end up making use of, and I mean, these cloud services end to end, right? For MLOps.
What does the color code imply?
Yeah, so you can read it here, right? If you have opened this tab at the execution phase itself, you can see what is in progress, what is succeeded, what is failed, what is cancelled, what has got error. So all those things also you can monitor from this graph. So there's another view for that. Step input and output also you can check. So suppose, let's say I selected this. So these are the details of the task. I can check for the input of this. I can check for the output of this.
With the help of JSON file. Is it a JSON file?
It's a JSON.
It's a JSON file. You can like, how to say, but it's getting logged on step function, which you can access also in your application or whatever monitoring tool you're using. Prometheus and Grafana are most commonly used tool for that. So you can configure the Prometheus with these kind of logs and populate on the dashboard.
The only
That's the next
is you need
stage
to know,
of the MLOps.
the only prerequisite here is you need to know
Input to the prompt.
prompt skill.
Yeah, this can be used by prompt.
Prompt skill is the prerequisite. That's it. Learn
So
it.
observability and monitoring of the resources and all these things can be taken care of. I have not done that, but like just theoretical part.
Man, it's
We've
so
already done a
crazy.
lot. Like,
I am familiar with Grafana and Form.
Okay. Nice. So yeah, apart from that, there are many alternative tools as well for Prometheus and Grafana. So you can think of.
DevOps.
Let's move to the next. Yeah, once this is passed, you can disable any of the transition while execution phase itself. It will not move to the next phase. So suppose you are working as a data scientist and you don't want to put the model into production, just make it disable from here itself. It will not transition to the production environment and keep running the pipeline till you are satisfied with your results. So this is pretty much about what was the demo. Code and all is available. Tutorial I am.
That's it.
कुछ और भी बता no one more stage is there.
I know there is something else this guy has.
probably the best one.
So much covered here.
Yeah, it's like he's covering almost like production only. He's an MLOps engineer, so yeah.
So yeah, once this has been put in the like
Mine was basics of MLOps, so I was able to cover only whatever is the basics of it. This guy went advanced.
But that's good, it's a flow. Start with basic.
yeah, managing the MLOps has been done. This also we have got. Yeah. So in managing, basically, if I talk about right, so in this you monitor for data drift, model drift, data drift. Let me click. And whatever checks you want to have, I mean, take in the accountability, those you can like manage over here. And also like load simulation, I was talking about it. That part was missing. Let me show you that as well. So once, I mean, there are two environments we check for dev and prod. So once it is in prod or dev environment itself, you can, so you should have a load. So if you're working for some, let's say retail use cases, right? And recommendation engine you are giving on a live website, which is getting used over there. I mean, even though retail companies doesn't deploy those recommendation engines live, they marketing team or whatever team is there, they get the data and then they start showing to the users. But few people are going live in the production with the models itself, right? So not for retail, but there are certain cases, use cases in the industry. So in that case, it's essential if we simulate the load testing as well. Like if we are sending millions, I mean, based on what traffic you can get on the for the model, millions or thousands. Thousands will be fine on some small instance as well. Millions, billions if you're going to that hit, right? So you need to simulate that level of test. Like how does Hotstar manages live streaming? They have done that level of testing with their infra.
Load testing.
Load testing. Their infra auto scales, auto down scales, right? Up scale and down scaling is taking care by automatically. Same you can do for the ML models as well. By simulating this kind of load, the number of instances will be getting, will be increased if the load is coming high automatically. If minimum, suppose if you're keeping 2 and max cap you have kept 10, and load balancing or testing for like 10 million or 50 million hits, and load balancing we just don't test at a single point of time. We try to fluctuate the traffic. So we need to simulate that kind of environment that traffic is fluctuating for an hour, for 2 hours of time, and we monitor that progress, like at what stamp of time, what was my traffic, what was my resource utilization, how many number of instances were being created, and different other metrics. So let me show you that as well.
Then this model has got a clustering. Clustering will be done.
Clustering means?
No, that algorithm, clustering algorithm.
No, this is a simple regression model. So this is the framework, right? You can replace the algo, replace the data, and make use of it. This is how it goes.
Algo depends on the
Use case, it depends. Yes. It's not the MLOps work.
Migration becomes your MLOps thing. Let's say you want to migrate your ETL pipelines from a regular AWS Glue to something like Elastic Stack from Elastic Company. There MLOps comes into the picture. Like migrating services, it's a different story.
Right. So in the code pipeline also you can check for different things. I'm not diving deep in that. Let's go to the SageMaker. In SageMaker, you can like notebook instance and all you can create over here. Endpoint can also be created. If I go to inference, I will have this endpoint over here. So these two endpoints you can see here, right? One is for dev environment, one is for product environment. So if I go to product environment, I have simulated that load in the morning itself. So let's have a look at that too. So these are the like dashboard where you can monitor the metric. Go to the view invocation metric. So these are the loads you can see in the morning. It's been populated, fluctuating traffic, memory utilization, disk utilization, how it went from this to this. CPU utilization, you can see it's fluctuating, right? And number of instances, like this is the limit I have kept, minimum to max 10. So when I was checking the load over on the instance while simulating that environment, it was going till 8, 9, like that. So I have not configured the notification part for any of the steps, but it is must when, as an MLOps engineer, you're putting some pipeline in the production, configure any of the like notification channel as well. Either Team, Slack is more preferred if you are working on projects, because that's when everyone is monitoring. So there will be a common Slack group or team group where the notification will be triggered automatically. So let's see what all we can do with this. So this is the last part. I'm just wrapping up. I will not take much
No
time.
problem, bro.
Yeah,
Continue.
you can take time now.
Take your time.
So here, if you go right, you can select the metrics, whatever you want to monitor over here. And you can select ways of aggregation as well, whether you want to monitor the value as it is, you want to take the sum of all the values, or you want to take the average value for that particular metric. And based on that, this graph will be populated. So let's say for this production environment, others and all also, like if some metric you want to, some error metric if you want to monitor, that also you can do from here. So I'm checking model latency. Let's select this from here. And invocations per instance, how many like hits we were getting for each of the instances as the traffic was getting, as the traffic was fluctuating over there, and number of invocations as well, like number of hits we were getting at that particular time. So once I have selected the metric, I can go to this graph metric, and once I'm here, you can select the period, like at what interval you want to plot these data. You can select the stats. So let's say model latency, I want to get the sum. Or let's say model latency, I want to get the average per instance. And invocation per instance, I want to get the sum of, actually these two should be average. Average per instance, average invocation per instance, and model latency should be the sum of hits all instances are getting at a time. Period you can select based on your own, like let's go for 1 minute hits. And I've not run this right now, right? So it's blank. Let's select custom time. And let's say for 12 hours, 10 hours I have picked it. You can see this load over here, right? Yeah. So if at any point I will go at this time, what was my model latency? What like invocations and invocations per instance. So these metrics you can monitor over time.
Can we able to monitor throughput as
Throughput means?
at a given point of time?
You can monitor that. So we have all these metrics are being logged with time stamps, right? So you can like check at minute level, at second level. You can decide like at what period or at what interval you want to check, and you can do that. So I think that's it from my side. Thanks for attending. Any questions?
Just have one question again with respect to security, because in the pipeline, right? So as a data scientist, you build a model, and finally you will be giving model artifacts and model files with some conversions, right, to a cross-functional thing.
Yep.
In order to do a prediction with a cross-functional thing, they have to unpack these models and they train it. I mean, the prediction basically. They're not train it, but they do a prediction purpose, right? So that point of time, again, their unpacking means they get to know everything sort of it, right? So model perspective. So do we have any mechanism with respect to secure that?
See,
Will there something called guard duty road service? Not sure.
even I'm not from the security side. DevSecOps, like that term is going on. I don't
Basically,
know like
in
what is
pipeline
happening.
itself, right?
Hmm.
Once I build the model, I'm ready with the model. I raise to the pipeline.
Hmm.
So, like, what does model do? Finally, it has to
Inference.
do a prediction.
Yeah.
In order to do a prediction, it has to unpack it, model.
Endpoint
it has-
API endpoints are there, right? You can secure the API with the
API is one way.
huh.
So, but
All the
you
models.
releasing this as a not as an API means the model will reside in your
Huh.
pipeline itself.
We
That
don't
is-
release the model, no? Like we see if some company is doing data science or ML projects, they will keep everything in their infra. So there is no security issue over here. Security issue only comes when you are deploying those model at some edge device, right? Or basically edge device applications also whatever is there.
API is the only way to go
API is
to
the
the
only way to secure that if it's going to the public out there.
No, not in public. Within our workflow itself, it goes to a cross-functional team. So if you wanted to release the model at all, so API is the only
API
way.
is the only way, right? They can make use of API gateways
Yeah,
with it.
which I was aware, but I wanted to see is there any
All
better
also give us
mechanism?
a Docker image, right? Container this stream you can store. You can
So inference container will again have at the end it will have endpoint only, right? Using which the inferences can be done.
correct, but we can, as he's saying that if you don't want to, maybe I think we can package it like that.
We can. So in this demo we did the same. Like there's a container, inference container, where we have deployed the model and we have given the endpoint for the inference purpose and configured that on the application. So yeah, endpoints are basically the
Yeah,
way to
again,
secure.
it-
Yeah, and it's up to you how you package that. Any other questions?
Security is a different discussion.
Yeah.
No, yeah, but if it comes under a pipeline MLOps, but I wanted to see any different views on it.
So the unfortunate thing is there is no security meetups in Bangalore. That's the unfortunate part. We have only developer meetups and DevOps meetups, no security. Security guys are damn busy, right? They don't have time to do meetups.
And they don't
They no
even.
need to.
And every hour
Again, there
they
is a
charge
secret.
guys like crazy.
Yeah.
Again, there it's a secret sort of thing. Right?
And they don't want to open that in public. So you will very rarely find someone sharing
Sharing it in
Dep-
the meetup.
yeah.
Difficult.
that knowledge.
But there is one group, I would suggest, there is a null group is there. Check, it's a Google group. They do monthly one meetup. That is the only security meetup in entire Bangalore.
Okay.
Okay, so there's some
we meet up at this group, null group.
null group. And null does it across India. So monthly they will do only one meetup. That too from 2-3 sessions they will do from 10 to 12 or 1, something like that.
But at least we can know.
Yeah. But that is correct. That is the only thing. Cyber security does nothing.
Yeah, because I think security is not, I think as you that they make money.
Yeah.
Hey, 8 minute guys.
They don't-
I think we ended the thing. I'm adding myself. So hey friends, thanks. Hey friends, thanks for being on the show and see you soon with a new webinar and also a workshop, as well as some series of sessions out there on Rapids and other technology. So I think you guys enjoyed a lot, and it's 2.5 hours of 2+ hours of stream, 3 hours almost. And thanks for tuning in, and see you soon. This is Vishwas Nayan signing off. Perfect.